on mic. There we go. How's everybody doing? Okay. Move some stuff around here. Had Julian here over the weekend, and we discussed synthesizers. Uh-oh, hold on. Got a window over here. I can hear myself. The music is very, very faint, isn't it? Well, it's about the same volume as me. I guess on speakers, everything is different. Okay. Oh, I'm here. I'm alive. Back this out a little bit. One thing I'm really reluctant about is the solenoid thing. Probably smaller solenoid would be good. Oh, is that autofocusing? Damn it. Hold on. Arm procedure, go. Herc. And it's back. And now we won't be auto-focusing. Let's check the other cameras. Face I did initially. Burn the subs isn't really looking at anything, but let's go ahead and get that one started. Yeah, it's just going to be a little bit close focused. And then, is that it? Oh, the microscope. How's that one looking? That looks okay. The trails? No, we're good. I mean, there are trails, but they're not serious. Let's back it out a little bit. I should be seeing like 2 inches on the screen. Those are square inches. That's what those squares are. Squares. So many squares. All right. So yeah, we talked about the features of the mixer a little bit, and I kind of know what I need to do. I just need to figure out what the schematic's going to be. And it seems like the overhauls are so extensive that I'm going to have to rebuild the circuit, the test circuit. I'm going to have to do the breadboard circuit again. And maybe I could do just like one channel. Well, no, because I need to figure out the relations between the channels and how those are going to work. Because a lot of it is like two unity gain inputs and then one stereo input. And the stereo input can be mixed with the unity gain input, and there's an overall volume control over everybody. It's like complicated. I don't know. I got to figure it out. And then 2 modes, one where the inputs are, if you plug 1 in, it goes to both channels. And if you plug 2 in, they're isolated left and right. The other one is where they're both center channels permanently. How do I do that? How do I do that without crosstalk and stuff? How does that work? I'll have to figure it out. Hey, what's up? Beef Dad, how's it going? Why did your chat not show up in my social stream blade? I have the chat popped out, and it's from this window. Beef Dad is a good debugging phrase for your microcontroller coding needs. And there's Madamu as well. Yeah, we're repairing stuff today. Why is my social stream blade not working at all? Close it and open it again. Social stream ninja. You know what? I'm going to do, close that down, and we're just going to do the web page thing that I have on the stream deck, just so that I get it all right. Web pages, that'll open a bunch of stuff. Chrome's going to like take a poop. This is why I'm low tech. Well, I need to do this kind of stuff to get everything up and running. By all means, the chat should be going to the stream blade, and it should also be showing up on camera now. No, I don't use Chatterino. I use a Social Stream Ninja. Check my plugins, I guess. Chrome extensions. What is it about? No, Chrome. plugins, extensions, Chrome extensions. These extensions were turned off because they're no longer supported. Keep for now. Keep this one. Keep for now. Keep this one. Does that mean it'll work if it's unsupported? Why did they break social stream? Oh, come on. Oh, and then I have to turn it on manually. There we go. That's so annoying. It turns it off. You have to tell it to keep it. Then you have to go in and manually turn it on. Stupid. All right. That, I think, does everything I needed to do. Okay. So now, I guess I'm going to reload this one. And hopefully this gets it working again. Let's give it a little idea here. No, it's not working. Do I need to restart now? Maybe open the page again. Let me close this, close this. How's it going, Ryan Labs? You guys aren't showing up on chat right now just because I apparently Social Stream Blade or whatever, the Social Stream Ninja didn't work out. It got closed by Chrome with that latest update. I'm going to try to get y'all back. Do these again. Google being a dick about what it does, what it allows. What's Social Stream doing? It's blocking ads. The new smallest MCU. I tried to order one, but I don't know where to source it from. I wanted to do it as a soldering challenge, but apparently it's been around for a while. I don't know. It just got popular suddenly. How these things kind of work. So, wait, where did you guys go? Okay, where's Twitch chat? Not there yet. Okay, so this is the other account. Minimize that. This one, and then I'm going to start up my web pages again. So I hit web pages, and it opens up the web pages, and then I take chat and I pop it out. Minimize this, and then I go to close YouTube. This one, I'll pull it up again. Put this one over here. So I can read you guys. This one I can close. This one I can close because I've already got it open. There and there. Now, if I say something in chat, it shows up. There we go. Okay, so we fixed it. I guess I didn't have to do the switch to Firefox. I could have just turned uBlock back on, but I don't know how long uBlock is going to support, because I don't know if they're allowed on the store and everything because of the new policies. So I did the switch to Firefox and it was super duper easy. But this computer is still on Chrome because of things like Social Stream Ninja. And I guess it'll be kind of a jump to get the stream computer over to Firefox. It shouldn't be too hard, but soldering it would be very difficult. Well, that's the whole point, is that I'm very good at soldering very tiny stuff. And it would be a fun little challenge to put it on a breakout. A breakout board. I don't think we don't really need Fusion 360 today. I'm going to close that application. Yeah, I'd be up for the challenge. I just can't source them. I don't have any contacts in Texas Instruments, and I don't think they're on DigiKey yet. Let's check. Let's check. Oh, it was giving me this one, which is not the smallest anymore. TI introduces the world's small. So there it is. I think I can solder that. I think I can solder that just fine. MSP M0, MSP M00, blah, 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 blah. Is that what we searched? Yeah, it is. Come on, DigiKey, where's the form factor? I wonder what languages you'd be programming that with. This is one thing that I dislike about a lot of MCUs is that you have to go to a very low level to program them, and so you might be stuck within the sort of devices of a particular company if you learn a particular way to program them. There's a lot of yeah, like that's pretty large. Yeah, I don't know what ARM Cortex. So what will we be programming with that? Board space. I love this wearable. Come on. Earbuds, medical probes, board space is scarce, valuable resource. Yes. That is very, very small, though. Power draw on it? Yeah. I mean, you have 8 pins, right? What are you doing with your 8 pins? Managing other digital devices would be pretty much what you'd want to be doing with this thing. Is it for ants? Yes. You could probably put one on an ant, and it would carry it around. There it is. YCJ DSBGA bumps down view. That's one of the problem with listing it like this with the circles. It's kind of weird to do it this way because you got to tell, you know, what are we doing? We're looking through the chip at the pins. Why call it PA 20 and 19? 24, 27, 20, and 19. It's like, you have 8 pins, just rename them. I guess it's in the package that has more, it makes more sense. Because you got your banks. Jeez, what a form factor. Like, what am I doing with this? Let's see, power draw. This would be the DSBGA. It's a DSBGA. We're just doing the business of the pins. And then we jump out and we go to 4.1 volt max. 4.1. So you can't even get to 5 volts of this thing. Applied to any 5 volt tolerant. Okay, so it can be 5 volt tolerant depending on. No, they're all 5 volt. Okay. VDD, IVDD, IVSS. So we're talking 80 milliamps ish. Microfarad. Run mode. 2-ish milliamps at 125 degrees. What? That's crazy. That's nuts. It's a neat little chip. I mean, it's very, very small. It draws about 80 milliamps, I guess. I don't know what I'd do with something like that. I mean, you could make a snortable computer. The mic is distorted. Are you guys hearing distortion? I wasn't hearing distortion. That might be you, brother. What's up, Sir Hiss? How's he? You try to talk in words. Something is wrong. Now I hear it from 2 people. Check 1 2. Slightly crackling. That could have been because I sat on it. Only when I talk. Ah! Ah! Still there. What's going on with channel 2? Channel 2 is reading something for some reason. What are you doing here, bud? Check 1, 2. Check, 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 check. Check, checkity, check. 1, 2. Yeah, it got a little hot. I don't know. Let's bring it down just a little bit. That's all the way up at the top of the orange, which it really shouldn't be. Loud noises. Okay, that's now it's clear. Yeah, I was right up at the bleeding edge of the orange on OBS. I don't know why that gets out of adjustment every now and then, but it's not like I touch it. I don't do anything to it. And then the second channel was coming in for some reason. It had something on it. Ghosts. So that should fix audio. One thing I am a little nervous about is going up to like 60 volts on the solenoid. It might enable us to use a smaller solenoid going up higher voltages in order to make this thing really kind of snap and kick, but it means charging up a big bank of capacitors. And I have a 100-volt meter that we can use now. It's a cheap-ass 100-volt analog meter that we can hook up to this thing, and then we can give it, I guess we would give it, the question is, can the MOSFETs handle it? Give it 60 volts DC from a Nixie tube amplifier that I have. And the Nixie tube amplifier can charge the caps, and you can see it charge up with the VDC. And I guess we should probably put like a diode in there. I don't know. I haven't heard this song in like 15 years. You know, it's a chill mix, and I don't know what Deckard puts on his chill mixes, but these are from like 10 years ago. These mixes. But then hopefully having a big bank of capacitors hooked up to the solenoid charged at 60 volts means that this thing will really snap and it can actually do some work. It'll actually flick the emote with some with gusto. There we go. My brain doesn't work lately. I don't know what's wrong with me. I think it's addling. It's starting to rot from the inside. I just can't think of words all the time. I think it just has to do with sleep. I just need to sleep and slow down and actually use my words. Use your words, father. Use your words. All right, so Social Stream Blade is working again for the time being. Oh, YouTube's not showing up. Damn it. I love you guys over at YouTube. Sorry, hold on one sec. I need to reopen your window. I think Social Stream didn't like it. So we'll open up the web pages again. This is like the third time I've done this. And we'll pop that out. I guess the extension needs to be running on all the individual tabs for it to talk to itself. Pop out chat. That. We need to get like an auto mod or a, whatever it is. The stream bot, Nightbot or whatever. We need it in YouTube. Gotta figure that one out. All right, so now YouTube should also be featured in chat, and I don't have the account to test that with. I guess I could just do it from the moderator. Where's that window? This is how moderated you guys are. I can't even figure it out. 1, 2, 3. There it is. Perfect. Okay. Everything works now. Everything works now. I got to make something that'll automate that procedure. Although that procedure was interrupted by, what do you call it? That procedure was interrupted by Chrome no longer supporting certain features. And I don't know why that hurt Social Stream Blade, but it also hit uBlock Origin, which I think is still running now. I think you can just turn it back on. Okay. But if I make the switch to Firefox on this computer, that'll solve all of those issues. Firefox is a little less smooth with the things I do with like ripping tabs out and popping them back in. It still does it. It's just a little less smooth about it. Yeah, it doesn't look like they have the super duper duper tiny package unless it's ill represented. What's going to be the part number for that? Oops. DSBGA. Which is which part number? Where is the ordering information? Usually there's a page with the breakdown of the part numbers. There it is. That's what I'm looking for. Package type. So MC1104S and then 3 letters there. Package type C table 5.1, and then we want DSBGA. What is, wait, oh. SRAM, 16 or 8. More's better. So we want the 4S8. YCJ is the YCJ. They don't have it. Aw. Yeah, they don't have the package. They probably would have an image of the package. I thought maybe they were putting a placeholder image on, but no, it looks like they just don't have it. Would have been fun little soldering challenge. Maybe one day when DigiKey gets that package in, we can try it. There's no way that I'm putting down super glue that's not larger than the chip. Like my dollop is super glue that's going to hold it down to a little bit of Captain tape, and then we use motor wires to get to the individual contacts. I have to use a better microscope than what they took that picture with, which I have. It's right here. It's a much better microscope, so we can get real stinking close. I can use my super duper duper fine tip, and then curse words will fly as we try to solder hair thin wires onto balls the size of atoms, these atomically sized things. That would be nuts. That would be nuts. It would be a lot of fun though. Yeah, don't sneeze. This is the only nasally soldered. What are you going to build with that? Who knows? An ultralight, hair thin computer. I mean, it's not terribly powerful, right? Maybe it is. It looks at 16K of RAM or whatever, 16 megabytes of RAM. What was the frequency? This is an old song. Yeah, I don't really know. 4 megahertz, 32 kilohertz. Optimize low power modes. 1 A to D converter with 10 external channel, blah, 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 blah. 10-bit, configurable 1.4 internal AC. Integrated temperature sensor. Up to 16K of flash, extended temperature, blah, blah, blah. ARM 32-bit Cortex M0. 24 megahertz, that's not bad. It's no slouch. That can certainly get out of its own way. Make my ultra super light RC car motor controller with it. Do all the RC car stuff with this one tiny little chip. No, that would be silly. Yeah, that BGA is cursed. I mean, that might be a little bit easier because it's only 2 rows. You know, you don't have these fully internal balls that you got to worry about, but that's still obnoxious. Honestly, they probably should have done. Well, no, because I guess if you're trying to minimize space, BGA is fine. Good for RC planes. Yeah, there you go. Does it have the usual array of peripherals? I don't know. I mean, there is an internal thermometer, but other than that, NVIC, SWD. There is debug. Beeper. PD0 peripheral bus. IOMUX. I2C0, UART0. It depends. I mean, the 8-channel or the 8-pin one, I don't think it has a lot of this stuff. This is for the ones that have more pins. Yeah, this one just has a couple. I mean, if you're really starved for space, I guess this thing is great, but 24, 27, 20, and 19. 27 would be an analog. I don't know. I don't know if they're doing the I2C. Yeah, 19 and 20. Oh, 19 and 20. So they do. Okay, so they are using the peripheral pins as the GPIO. So they're, I mean, like with a device like this, you would, of course, like most of its job is going to be like communicating over I2C, right? Because you really you need exterior stuff. You're not exactly going to be doing heavy pin things with your 8 pins. So this would be like a signal broker for I2C and whatever else. These don't, do these take and reset? Yeah, that's SW clock. These don't do USB natively. Craziness. I don't know what this is all about. Timing 0. Craziness. But yeah, that thing's tiny. Wow, what's with the delay on YouTube? At least on mine. Oh, it's not live. That's why. Well, I don't need to see it right now. Okay. Minimize that. Bring this back up. This isn't going to take us very long today. We'll see how much time it takes up. But we're repairing a delay that Julian built. And let me tell you, I don't think I've ever seen a 7805 blow up this badly. That little guy right there is a 7805, and it is not in good health. It is not in good health. So we'll get this thing out of there because it belongs in a museum, and we'll figure out why it died. We got to take a look at the circuit a little bit, do a little research. Who built this delay? We might have to do a little trace repair too, because when I pulled the capacitor out, the trace popped off, and I don't know what is what with these caps. I don't know which one goes where. It became a 7800. Wait, the 7800 was actually a thing. What was it? I think that was an actual chip. And hopefully this thing isn't dead. It's PT2399. We'll take a look at that chip as well and figure it out. And this is another in a long line of things that Julian has DIY'd that end up blowing up that I need to fix. So love Julian, love him to death. He's getting better at electronics. Wish I could have been there to help him with this a little bit more though. I love these. So these synthesizer guys rely on this thing here, right? They call it a Vactrol, but really it is just a diode, I think, or is this one a lamp? Sometimes it's an incandescent lamp, sometimes it's just a diode, and then a photoreceptor, either diode or photoresistor, and then they call it a Vactrol. Whereas us guys, we just put the two in a piece of shrink wrap and call it a day. Yeah, Bezier curves. No, this looks like a particular person's circuit design. The same one that built my or built the circuit for my wobbleinator, whatever it's called. I forget what the thing is called. They make one circuit a month, basically, and they've been doing this for a long time. And so their traces look like this, where they just kind of very quickly click, 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 in order to get the stuff to where it needs to go. Is that a real part, or has it been remarked? I think they got the plastic made and shoved the diodes in there, because you can only buy it from like one place, and it's just some guy's website, right? And so people do use these things in their circuit design, but it's like, dude, we've got other versions of this that are cheaper. People just insist on getting that one. I think that person, I think that, are they Australian? I forget, but they really should use either Topor, or they really should have what do you call it? Blah blah blah. I'm trying to remember. Just draw the traces with curved traces. Yeah, it's just a piece of, okay, so what they did it's custom for that company, because they sell it like it's a component, but it's really kind of not a component. It's just this plastic box that they put around a diode and a photoresistor. Actually, that looks molded around. It looks like they're molding it around now. Yeah, they sell it as its own thing, but we know what it is. We know what it is. We know what it actually is. They're not fooling us. We're better than that. Now, why aren't these caps on the other side? I guess maybe they'd interfere with the front panel, although these would interfere with the front panel too. I guess they're just a little too tall. I don't know. Julian built this thing, so we'll have to figure out what it is and look it up. Yeah, they might just have black epoxy and a jig, yeah. But all it is, and you can buy like opto isolators. I'm gonna guess there's probably an opto isolator that matches the specifications of this thing. I'm gonna guess that. The colors are off on this, so I'm gonna do the procedure on it. No, colors are still the same. Never mind. Maybe it's because of the amount of light that I'm putting in. Here's something. If we're out of focus a little bit, and I close the aperture, we get in focus. Pinhole cameras are neat. In an amplifier I took apart, they made one of these by shrink wrapping a flat-faced LED to a flat-faced photodiode. Yeah, that's all, and that's all a lot of the designers tell you to do. Like that was a big facet of those old electronics books, is making your own voltage isolators by shrink wrapping two devices together. It is a long-known thing, and even in the not Mike's Electric stuff, it's what the fuck was that? Oh, the straw from I have a cup behind me, fast food cup, and it's full of ice, right? And the ice is melted, and it made an airlock with the straw. But as the ice melts, and the temperature in here is getting a little cooler, the pressure difference. There's a pressure difference between the air inside the cup and the outside air, and so it suddenly just went. And I was like, what the fuck? And that's because it finally overcame the bubbling, the depth of the straw in the liquid. Excuse me. Project 93. Project 93 is the microphone that I use. That guy's website. I forget what the name of it is. They have basically the same thing in their amplifier, and it's. I guess it's also a way to compress too, because the light's only gonna let so much current through the resistor. I guess is the thing. But yeah, the Vactrol VTL is a particular type that, I don't know, the modular synthesizer guys seem to love these things, because Julian has multiple devices that have used one. What's up, Ben Gizmo? How you doing? Bezier curved traces. I can do Bezier curved trace circuit boards with Fusion 360. I need to get back to that. I haven't done any circuit design in the past couple days. I've been nigh on borderline overwhelmed just by nothing. I don't know what the deal is with my brain. Maybe just I burnt out a little bit, but I'm getting back to it. And as I do, I've got sort of a more finalized version of the mixer board I need to test, and I need to work on that keyboard circuit. I want to get that keyboard circuit done, because that's something that I can put away really quickly. Keyboard circuit goes together. We test, which we could do a little bit of today. We could actually test cutting the edge of that circuit board and see whether or not that'll allow the solder to bridge to pads, because that way I can move all the traces to the top side and just have them up near the edge, and I'll come in with a knife later and cut them, and then I'll be able to do that little solder bridge. For some reason, having that 0.2 millimeter edge spacing means that I couldn't get solder to jump that gap. So instead of having the pad, ideally having the pads on the underside, that'd be great, but that doesn't help. Well, that means that I would need a lot of vias on the circuit board, which aren't too bad, but I just don't even want to need the vias. I don't want to have to put 35 vias in order to get all the signals to the top layer. What's up, Hairbothan? This thing is inactive right now. The Node Red flows are still going, but it's not plugged in. Oh, this one. Really, Simon and Garfunkel? I gotta flip the mix. This is a little too. It's like listening to girl talk. Ugh. I don't like girl talk. I think it's very basic. It's too basic. I'm flipping mixes. This is too many. We keep running into it. It's like the 1960s mix. Come on, man. XII. I don't know. I think we already listened to this one. I can't fast forward. I'm not allowed to fast forward because I'm a filthy pleb, unwilling to pay for 9,000 different services. But it's only $1. Yeah, no. Thanks. I'm allowed to say no. I had to. We were working a festival, Camp Bisco, when Girl Talk was at their height, and they were at Camp Bisco, and so we had our camp right adjacent to theirs, or to the main stage, and even through earplugs and earmuffs over the earplugs, I was listening to Girl Talk, mostly through the ground. I was like, I hate this. I hate it. Yep, all that stuff. I feel so nickel and dimed. It's like, you want our streaming service? Cool, give us like $5.99 a month. All right, well, you know what? The streaming service has a lot of stuff on it. And then they're like, if you don't want to see ads on our streaming service, it's another $2. And you're like, wait a minute, I feel like I'm being like fucking robbed. Like, I feel like it just leaves a sour taste in my mouth. They They keep inching you to rob you a little bit more. Yeah, there you go. That's where it's at. Sorry, Ben Gizmo's intro was a fart, but I didn't have the thing plugged in. It's plugged in now. It's plugged in now. We don't have this one going. Did that one have its own command? No, that was just the awe emote, so I don't have to do anything with that. He's just made it out of the box that I was looking in. This goes away. Capitalism Daddy said rent seeking was the most capitalism thing ever. I walked in and farted. He just crop dusted the whole lecture hall. Yeah, it would be more economical to use this one, to use this solenoid. It's slightly smaller. It's got a shorter stroke, but I don't know if hiking the voltage up with this one. I mean, I spent $20 on this one, so I guess we're gonna use it. It seems like it might be a hell of a lot more violent when we give it higher voltages. But that capacitor circuit scares me. That has me a little bit nervous because it's going to be a 60-volt circuit where I put a little voltage regulator that will charge up the capacitors. I don't know how we're going to cut off the voltage, though. I could put it on another one of these things so that we power it up, or we connect it to the rest of the circuit. It charges up the voltage. Then when we set it off, we cut off the voltage regulator, cut this thing, close this, and then this runs out of power, and then we turn the voltage regulator back on. Would it sit that way, or would it just do that when it fires? It should probably just do that when it fires. So it'll fire off and then wait, and then when there's a redemption, then it'll charge it up and this thing pops. So it'll all be timings. But that means that my capacitors don't stay at fucking 60 volts. And hopefully we don't pop off any of the capacitors as well. God. How can you not acknowledge a barnstormer like that? You got to at least just say like bean burrito, and then you got to keep going. Something so fundamentally disruptive. Where'd the voltmeter go? Here's the voltmeter that I got. This one I will be able to find a 3D model for it. It's a little big, but it'll be fun to see it. When this thing operates, it'll be fun to see it like come to life and then it'll pop an emote out. That thing will be really cool. It's a nice big one too. It's a 100-volt meter, and it was like very cheap. So I don't really know what I'm going to be getting out of this thing. Very reputable brand, I think. I mean, 60 volts is a lot of volts for this thing to measure. DC. It's a nice looking. It's very light. It does not feel like it's made out of anything quality. Move this stuff back. It's out of the way. Although it is nice to have like a staged setup. Bam, bam. As long as it works. Well, that's the other question. Does it work? Do I have what it takes to even test it? I don't know. Do not know. Needle gauges are a settled science. Not when your margins are super tight. Who makes money when I buy this stuff like this? I don't know. I guess whoever the supplier is sells a certain number of them, and that represents their revenue. And then it sits in a warehouse for me to buy for a very tiny little margin. Pennies on the dollar. I bought a winch last night. I'm gonna hook it up to the DeWalt batteries and see how it does. See if I can power it off of my battery packs. And I'll have to make an adapter for it so that it has a hook on the other side, because it's a very small winch. It's for like ATVs and stuff, but I think it'll be pretty good for things like lowering tires down and just silly stuff like that. How much copper can we shave off of the coil before it bursts into flames? Yeah, exactly. How thin? When does the varnish actually cause arcing? When are we going to be liable for the fire instead of the user? This should be fun today, though. Julian DIY'd this. We got to check the directions of all the capacitors. I think that maybe was the major downfall of the rest of this thing. We'll have to figure out whose circuit it is. There's a bomb on it. It's just in the corner there. I don't see a lot of identifying markings on it, but I think I know who made this. It's the same person that made my oh god, what was it called? Hold on. Let me go see what it was called. I gotta walk over to my synthesizer over here. Brain Custard, that's what it's called. So we'll look up that guy's circuits, because I think their signature is the type of trace layout that we see here. Yeah, exactly. Well, okay, so the problem is I removed one capacitor. The thing that really made me like turn to Julie and go, listen, this is going to take a while, is when I looked at the one capacitor. I removed it, and of course, I also philosophically disagree with whoever made Brain Custard, because they put the value of the components on the board instead of a designation. It should be like, C1, C2. Oh, we can just look up the name of the thing then. Okay, cool. But when I remove the capacitor, what does that mean? One is a square lead, one is a circular lead, and it's just got two little bars on it. I think I am, yeah. And I didn't know that it was them. I didn't know it was them until I saw these traces. Nobody does this except Julian Lett. Is that? Oh, no, when I say Julian, I mean my Julian, the guy I know. Dive Bomb 3. I don't like this track. No. Tear apart tapes. Maybe that's not. Who does Brain Custard? Non-linear circuits. So that's a different person. Oh, multiple people are doing that kind of trace layout? See, this is what I'm talking about with the traces that are just like cursed. But apparently they make a new circuit like every month rather. Okay. So Dive Bomb's a different person entirely. Where are the instructions? I wish this song would end. We'll be through with it in just a minute. Oh, tear apart tapes. There we go. I can't skip it because I don't have the privileges to do that. I may or may not have drawn a smiley face in the traces on a middle layer of a commercial product. That's not very brave. That's not very brave. I've drawn penises on things that I've made before. One that I saw was on one of those little buzzers for like a cafe that you get. Here's your thing. When you buzz, your seat's ready. On the PCB, if you put it up to the light, there was an area of it where on the 4-layer board there was just a blank spot, and actually the light coming through showed the middle layer. And the middle layer, it was an American flag. It wasn't that exciting, but it was kind of cool to hold it up to the light and see the secret. funny how circuitry components are only there to manipulate the frequency and electrical properties. That's what they do. Like, what do you mean? What do you mean? That's what they do. That's not funny. That's what is. Funny how rocks are there because volcanoes were a thing. Like, it's just what they are. Wait, this didn't. Where's my info? Dive Bomb 3. That just takes us back to the website. This is module. Why am I on Modular Finder and not the actual website for Tear Apart Tapes? Tear Apart Tapes. Are they only on Etsy? Modular Grid, Facebook. I'm not going on Facebook. Discogs. I guess we're going to have to just look at the circuit. We're just going to have to look at the circuit. I mean, our understanding of electromagnetics and the relationship between magnetism and electricity and how that relates to like wireless signals and things like that is so very thoroughly explored that inside of a device like my oscilloscope, there will actually be traces like copper on the board that is specifically shaped in order to manipulate high frequency signals. So you can make a capacitor by putting two of the traces next to each other in a particular way. If it's a pointy one, or if it's a cone, or if there's like a circle on it, it'll manipulate it in a specific manner. You can do capacitors that way. You can meander traces so that they have the same resistance, and so that when you're on a microscopic time scale, completely unfathomable to the human brain, on a micro tiny little fraction of a second, as those two traces are coming up to a voltage level to indicate a 1 or a 0, as they move, if they've got the same amount of resistance, that signal's gonna move together. And so those 1s and 0s get to their destination at the same time. Most of the time, you can think of the entire trace, because this is going near the speed of light, the entire trace is representing the 1 and 0. It's not like what they show on TV when they're talking about digital stuff, where you've got a 1 and a 0 traveling down a line. That's not how it works. It's not a highway. It's the whole thing is getting up and down on the voltage levels. So the whole trace is doing that. When you get to super duper duper high frequencies, then yeah, you can see, you can have that kind of thing happen where you've got multiple signals that need to get to a destination. They would both populate the trace at the same time. But generally speaking, that's not the case. So that's what I think is funny about this whole thing, is that the entire trace has the 1 or the 0 on it, and you meander those traces in order to get that 1 and the 0 to be recognized simultaneously by whatever you're sending them to. I got dry mouth. Why is my mouth dry? It's because my glucose level sucks right now. Okay, we're plateauing. It's going to do that for a little while. I had a little bit too carby of a lunch, to be honest. So I'm gonna be slamming down these seltzers. I'm gonna get seltzer drunk. Slamming down seltzers just to keep my kidneys flushed. Good times, good times. Now, can we test this delay? Yeah, I think we can, and I think we can use this bank too, the routing bank that I made. So we'll put a signal into it. We got to figure out what all the ins and outs do, and then we can observe it. Do we get like a? I don't think we even get like a manual. Bandcamp, Etsy. Tear Apart Tapes, Record Tape Magazine, Eurorack modules. All right. Where's the bomb delay? Dual Atari Punk. Filter module. Bomb 3 is what we're looking for. Dive Bomb 3. This is an assemble module. Is there a guide for it? Is there a non-assembled? I'm guessing there's a hit form. of Dive Bomb 3. Dual air. I'm looking at the kits right now. Bus board, baby. Diode clipping. Speed bump. They only sell it complete. Or maybe they've been bought out. No, dive bomb delay. At the very least, we'll have the front panel to work with. No instructions. Where are the instructions? They just send you this stuff. All right. Well, we have the front panel. Yeah, we can at least repair it based on the front panel. It's strange to me that they would put capacitors on the back side of it. Yeah, they do. They just have capacitors that sit on the other side of the board. It seems like a bad idea. Because like these will get damaged pretty easily. But what we'll do is we'll take those caps away because I need to actually get to the voltage regulator pins. And I got to be real careful about this because the adhesion of the traces to the board is not great. They could have done with like a ground plane somewhere on this thing, you know? You guys ever hear of a ground plane? I guess not. I would like to take a look at my brain custard and try to like really slow it down. I want it to be a low frequency oscillator because I want that weird randomness to kind of infect into the rest of the synthesizer. I think that would be fun to have at low speeds. I don't have a lot of low speed stuff. But then, I mean, one of the really pressing things that I need to do, it's getting cold in here. I'm going to close the window in just a second. One of the really pressing things that I need to do with all the synthesizer stuff is I need to actually make the module tester module so that I can go through all of my stuff and make sure that everybody's working properly. That's the one thing that I have not done. I've got a couple things that I would like to be working, and the synthesizer as a whole is not functional just because I haven't put together the disparate modules and been able to work with them and learn how this stuff works, how to put all this stuff together. Julian recommended to me a YouTube channel where the guy is pretty good at explaining what he's doing, although it's tough to watch. It gets kind of boring, but it's cool to see him actually speak about what he wants to get out of like a connection and what's going on in one place or the other. Pretty cool. Window. I'm going to go handle the window. I'll be right back. Actually, I'll still be mic'd. I am so discombobulated lately. And if we get through this repair quickly, I mean, that's that for stream. That's just how I do things, is that if the narrative is solved, I'm not going to spin my wheels. So we got a little bit of work to do, but it might be a very small repair. Yeah, let me get the music out of here. Let's just start. This is also a mix that I've heard many times. I need to find the other chill mixes, or just find new music. I don't know. I haven't branched out. I haven't gone and like explored and looked around for cool music to play as an intro. Now that the stops have been pulled out and I can use any music, yeah. I'm gonna burp. Okay, I'm back. Hi. So you guys, I mean, I couldn't help but start on the project. The project is Julian bought this kit and he built it himself, and that's all well and good because I'm really happy that he's kind of learning electronics and how to solder and stuff like that. And for the most part, the kit looks perfectly fine. I think he did a great job building it. What we need to do is come in here and pick up the broken pieces, because whatever he did, something really bad happened. And the 7805 voltage regulator took a hit. And he was like, I don't know if it's going to be like a rare part, like something that you don't have or might need to order. And I'm like, I'm pretty sure if you blew up a chip, it's going to be the voltage regulator. And I got plenty of those. So it's an LM7805. Of course, I've got tons of these things. I don't think he built it. He didn't. No, I think he built it. Yeah. I don't think he got the pre-built kit. Some weird choices on this board, though. Capacitors on this side, I guess just because the caps are so big that they wouldn't fit under the panel. But like those guys are on this side. Maybe these need to be bent down a little bit in order for the panel to fit. I don't know. Be careful with those. I don't want them to break off. We won't touch them again. I just kind of pushed them down a little. Those should have been soldered so that they were able to be, they were able to lie down. But whatever. Anyway, the point is, you know, the kit is built. It looks okay. It looks like it's tolerable. Oh yeah, those are off by a bit too. Wow, this is this is some engineering here. Yeah, everything looks okay. I mean, for the most part, things are put in correctly. He was mindful about what he was doing. These are a little crooked. I feel like surface mount soldering with a hot plate is easier. You don't even need a hot plate. You could just do this in the larger surface mount sizes and it would be a much better board for it. Yeah. Although the surface mount capacitors are kind of annoying. The ones with those long leads that go under it and essentially just a can sitting on top. I would prefer if this were surface mount, especially, you know, if this was something I was building and deploying myself, I would prefer that it was surface mount. I think surface mount is easier than through hole. Controversial opinion. So we're trying to get to the voltage regulator and we want to replace it, and then we want to check over whether or not the capacitors are facing the right direction. Their capacitor symbol, just like their potentiometer symbol, leaves a little bit to be desired. What the hell is that? You know, look at that. It's awful. It doesn't, your component is supposed to be framed by the silkscreen layer. That's miserable. That's absolutely miserable for whoever's designing these boards. I hope you're okay. I hope you're happy. maybe on one of the boards you could leave a trace that is like a cry for help. We can maybe get that information out. I'll send my people to go recover you. Critiquing his circuit. I'm not talking about Julian here. I'm talking about whoever's designing these boards. Did they hurt you? But like, look at that. That's such a dog shit symbol. Like, put a plus or a minus on it. Which way is it supposed to face? Is the stripe supposed to go? We'll look at this in terms of how it's hooked up to the circuit. We'll look at which one is the positive and negative because we're right where power's coming in. I'm just going to take away these two. Do they look damaged? They look okay. Yeah, they look all right. So let's get those out of there, and then we'll check it over, and we'll get a new 7805. I already got a 7805 out of the parts bin. I got one right here. It's been sitting in the parts bin for who knows how long. 78L05 BP. We'll put that one in there, and then we can power it up and see if it works. But we've got to, if some of these or one of these is backwards, we probably have to check over the other ones too. I guess I have a picture of the circuit board over there. Oh, but it's the wrong side of the circuit board. Darn it. Okay, well, let's get started. Let's get started. Okay, so iron is on. I've got the semi-large tip. That should be okay. We're doing through hole, which is very annoying, and I don't have a great way to hold the circuit because it's so big. I guess I could put it on the stand, the big circuit board stand. Let's try that. Where is that? Is it to my right? To my left? I actually think it's up there. With my strainer. No, it's not up there. Oh, here it is. That's right. So we repaired this with glue. Hopefully it's okay. Oh, I hate when I move the camera like that and it's actually unscrewing my camera mount. Very annoying. Yeah, this stand might actually be pretty useful for this because it's got these big big capacitors sitting out the back. Probably better if I hold it like this. That'll get the iron away from the jaws. Put a lot of pressure on it. Tighten it. Just gonna limit spinning, and I'm okay with this spinning. Okay, so getting to these guys here. I gotta remove this one and this one. And I have to do it in such a manner as to not pull out any traces that are on there. I actually think maybe I need... No, I'll keep to this iron. We'll stick to this iron. Do I need the microscope for this? Probably not, and I do need tweezers. I really despise through-hole. the reworking on through-hole is very annoying. Yeah, this is a former 7805 for sure. For sure. I guess I need a ton of solder on this too. We'll use the big rail solder. Use this big guy. Oh, the thermals, where are they? Where are my thermals? Where's my thermal camera? Is it on? I see... Let's see the LED on. By all means, they should be working right now. Give me a sign of life there, thermals. Nope. Okay. All right, unplug. Plug back in. To be fair, the thermals really shouldn't be working, running 24/7. As they are configured right now, they do. Thermal, that's here. Properties. No properties? Did I miss the button? Yeah, I missed the button. Deactivate, activate. There we are. All right, those are an important part of the whole soldering thing. All right, thermal images is up. So now what I'm going to do is I'm going to add a bunch of solder to these two pads, just because I want the capacitor to come out clean, and I want to make sure that I give the pads time to heat all the way through. This board is kind of cheap, and it's kind of like, it's like, I don't know, it's the adhesion of the copper layer to the board. I mean, I'm glad there's a solder mask and a silk screen, right, on both layers, but it's way too easy to pull up traces on this thing. And I think Julian bent the leads so these don't just fall out. They have to be pulled out. What is that? It's probably stuff from in here. So that's one of them. I guess I can use the Engineer SSO2 to suck solder away. Clean this pad off. Yeah, looking good. Through-hole repair, man. This is a 1970s technology here. There we go. Yeah, a little solder braid on that shouldn't be too bad. This is my Visual Asmer channel. Visual Asmer desoldering channel, 24/7. Social solder sleeping channel. All right, that is textbook. Whatever the hell I did to the other one was a crime. I did this one too quickly and I pulled a pad up. Terrible. I feel bad about it. This one here I would like to remove. That shouldn't be too bad. Same procedure. It's easier if I just get both pads molten at the same time. If you're professionally repairing through-hole stuff, sometimes you just clip the component away and then deal with the pads, the little leftover wire from the pad. But in our case, we kind of need to save these caps. These caps may or may not have blown up with the rest of the thing, but yeah, anyway. I'd like to give Julian an assessment of whether or not he built this thing properly once we're done. Where's my Nipex? There. What expensive flush cutters for a reason. Okay. All right, a little bit of desoldering on this too, on the four actually, the four of them here. We'll use the air desolder. See, the other part is that we are way too close up. I can't get further back than this with my setup. With through hole, I mean, I could be doing this with my normal eyeballs. I'd be perfectly comfortable at it. Now the thing is, the trick here is I want to preserve the voltage regulator because it's so righteously blown up. I think that is like a trophy. I should make a necklace out of it and give it to Julian. Is that a lead in there? What is that? A component that thing's gone. There shouldn't be a lead in there. I guess that's whatever's left of the via. Maybe that's the one that I desoldered. Huh. Why is there stuff in it? Like a Prada bag. Got a Prada bag with a lot of stuff in it. Jiggy with it. No. I like that line. I have a bag and there's stuff in it. Sure do, my man. Sure do. Now, what is that stuff? I'm going to poke it with a pin tool. Get the pin tool, poke it. Give it a poke. Are we still out of focus? Ah. The focal length is hilariously tiny. Okay, 3 cap spaces are opened up. This is disgusting. We'll clean the board a little bit too, so we're not swimming in filth. Ugh. We will clean the board. We will do that. That way the markings will also be a little bit more clear. All right, so let's get the subject of this whole thing out of here so that we can laugh at how blown up it is. Oh my God, it's like a whole chunk of it's missing. I'm surprised there wasn't a fire. All right, so we're really close to that connector. I'm just going to I am going to move this, reconfigure, remove, what? What are you saying, Bother? I don't even know. I don't know why I'm like this today. Lately I've been like not able to come up with words that I'm trying to say. I think I'm just like burning out like on a fundamental level. It's just this major sort of brain rot that's starting to get to me. I want the solder to be away from all this plastic right here. Did the dude that make that have cats? He has 3 dogs, sometimes more. Too much TikTok. No, I'm not on TikTok. I'm just using that word. They're going to start to claim it's their word. I think the ADHD has gotten kind of bad. I think I need to take Sunday off from the medication. If I take Sunday off, then I can build my tolerance back up. Maybe then the meds will actually snap my brain into a normal mode. Regressing to monkey. Ook, ook. Sometimes you want to sit on a rock and just look at a bug. Let your brain go back, go all the way back to what it used to be. Become Joe Rogan. All right, hopefully we didn't pull a pad. That was a little bit more force than I would have liked. That's not looking good. Maybe that's just an excess of solder. Let's check the other side, and we'll desolder from the other side, so I'm not threatening that connector. All right, we still got all our pads. Now, a lot of this flux is mine. Some of this is Julian's. Unfortunately, when I do a repair like this, I'm sort of taking the reins from Julian, and I'm saying, you know, let me do this, let me do this. And then I did the same thing when he built his Fat Man, which is a synthesizer. He built a Fat Man, and I totally rewired the panel because it was very sloppy. But that sloppiness would bring into it like his work, right? And so I kind of took that. I felt bad. I took that from him. I took sort of his agency away from having done a project. I don't want to do that with this, but I kind of, you know, we have to do our work on this, and he came to me specifically to repair this. I just don't want to like rob him of the experience of getting a thing to work. But I guess it's what he requested. And you know, as much as I worry about this stuff, he'll probably be like, "Don't worry about it. No, it's fine." So I don't know. I don't know. Yeah, giving the controller to Big Bro. Yeah, and then I beat the boss and give it back to him, and it's like, do you feel satisfied? Like, listen, you guys, some of you were there for my ODST stream, my Halo ODST. My buddy and I are big fans of Halo. I mean, we've been playing that game from the time it was released. I remember in science class, my friend and I were really champing at the bit to get home and play Halo for the first time. But I remember that day. I think it was snowing. So we had like a snow day the next day, so we were able to play a lot of Halo. But we did an ODST stream with one of my other friends who's a big fan of Halo, and it would essentially be me entering an area to a bunch of dead bodies. I was like the little brother with the controller, with the controller that wasn't plugged in. He'd go into a place and he would like completely clean the place out. He knew exactly how to do sort of the chess game that is sort of the Halo combat. And then I would bumble in and say, "I'm helping too," and then get killed. Just something like that. It was an experience. I got zero satisfaction out of playing that. It was fun to hang out with my friend on stream, but it's still. Oh, and then somehow with this guy, I told him, no World War II. We're not mentioning the war. Don't talk about the war. And then somehow in the middle of it, he had a huge discussion about tanks with somebody in chat. I was like, come on, man. Some people. All right, so what do I use in order to clear off all the nasty flux? I use Goof Off. People go, you got to be careful with the acetone around plastics. Oh yeah, you absolutely do. But the plastics that they use in electronics are usually a little bit more resilient to that sort of thing. But you don't give it a chance. All right, let me finish hiccuping here. You don't give the plastic a chance to melt into the sort of Goof Off orange flavored acetone. I like using this stuff. It's stinky. It's just the old school electronics guys used it in the FBI lab that I worked at, and it works really, really well. So I use Q-tips because they are they're grown on a plant and made out of a tree. This is all renewable. Somebody sent me at some point plastic Q-tips, and they had this very weak foam on the tip, and it was plastic. You worked in an FBI lab. It was an electronics lab at the FBI Technical Center, yes. I didn't work in the lab, though. I just had access to it in order to reverse engineer IEDs, among other weird things that come with that sort of work. But yeah, I worked with the electronics lab, actually both of, the electronics labs there. And I worked with tracking devices as well for a little while. But yeah, some of the technicians there loved their Goof Off. So just a little application of it. And that area of the PCB looks brand new. Now, let's get it over here too, I guess. It's going to get chewed up by the pins. Yeah, I don't want to leave all these fibers behind, but either way, at least it's a renewable kind of resource here. The ones that are plastic, they might seem cleaner, but they just seem like an environmental disaster to me. Whereas making them out of trees, you'd grow new trees. Remember, electronics don't heal. You do. You heal. So put yourself between the machine and the work that you're doing. Because you can heal. It can't. Profits above all else. brand new circuit board. That's what that looks like now. The process for reverse engineering, it's the same thing I do here. You just have to have gumption. Figure out what the ICs are, figure out what they do, look at the data sheets. Most of the time, engineers aren't creative enough to go beyond what the data sheet says to do. Put that into a schematic. That was most of the job. I mean, most of our job was authoring documents. We'd write documents about how the things work. And then we publish that to sort of a nebulous intelligence thing because we don't know what the next step is. That was compartmentalization. Compartmentalize. So the people who are the eggheads who figure out how the devices work and how they relate to one another aren't the people that are writing the intelligence documents. We just write what they base their documents on. So the stuff you see me doing today, similar to what we did. We were a little bit more documenty. Yeah, I want to clean up some of this stuff just for the sake of having a clean circuit board to work with. Oops. I always wonder about the ultrasonic cleaner, what I would have to do with that, because I recently got an ultrasonic cleaner. I just don't know what chemicals I would be putting in the ultrasonic cleaner in order to clean off a PCB. If it's simple green, I think, wouldn't that get into the electronics and blow them up? So I don't know what I'd be using. But one of the important things about what I'm doing is I'm also drying it off with the other side of the Q-tip. One side's wet, one side's dry. And that way I can remove the bulk of the acetone before it can get into the plastics and stuff. Hopefully I'll leave behind a slightly cleaner board. Over here. Some lines and squares, how you doing? Yeah, we're having kind of a quiet stream today. It's Tuesday, probably not a lot of people around. Assassin's Creed is out, so everybody's going to be playing the same game, which actually, I don't know, is that a boon to my channel or... Yeah, anything else? Well, it'll leave behind the stuff that's in the acetone if you're not careful. So you can actually end up spreading the flux out. You can spread a thin layer of flux on your whole board. I wonder if I get more or less viewers when all the streamers are playing a game that they've been paid to play. That's why, you know, oh, it's not their usual category of games. That's weird. That's when they're getting paid by the game company to play the game so that they get coverage and everybody goes, oh, that game's out. Oh, I guess I'll go buy it. The problem with through-hole is that it tears up the Q-tip. It tears it apart. And so I end up having little bits of cotton all over this thing. I feel like I should be taking the toothbrush to this. Actually, that might be a bad idea. Toothbrush is going to not shred like this thing. What was the last thing I did with the toothbrush? Is that clean? It's relatively clean. Brush your circuit boards, kids. You'll get plaque buildup otherwise. See, near the jaws, it's less clean. Okay, cleaned off. That'll be a nice, newish looking board. Now, let's figure out what the symbol is. Let's figure out what their capacitor symbol is. It's likely that they put a mark where the stripe should be, but I just want to verify that. Yeah, there's little fibers all over it just because through-hole catches that kind of stuff. There's no getting around that. It's just going to be a little bit fibrous. Use a little electronics cleaner spray. We didn't get in there. Let's get in there. Let's get kind of in there. Dog's barking at stuff. She takes it on as her job to keep the family safe. She's the guard dog. And we didn't tell her to do that. We didn't train her as a guard dog. That's just her instinct, I guess, as a herder. clean and ready. Look at that. Beautiful. Beautiful. Would I die immediately if I licked that clean board? No, but you sure wouldn't get a good flavor out of that. I don't know if you've ever worked with acetone. You would definitely scratch your tongue because these through-hole parts are sharp. But it wouldn't be a picnic. I mean, I've done it before. When I was doing the Goop 3D printer, the resin printer, I didn't wear gloves for something that I did, and I got some resin on my hand. Okay, well, that's not a big deal. Eventually, if you do that too much, your body will start to develop an allergic reaction to the resin. So you gotta be careful. Okay, I gotta be careful. I'll just wash my hands off, drop a little bit of rubbing alcohol, because it's alcohol soluble, on my hands, wash them off. Easy peasy, lemon squeezy, everybody's fine. No big deal. Later that night, I forget what I was doing. Oh yeah, later that night, I'm sitting at my computer watching some stupid shit, and I go, my fingernail is getting a little bit long. So I put my finger in my mouth to bite off my nail. That got resin in my mouth. I have gotten 3D printer resin in my mouth. That was not pleasant. Months later, I was going to a birthday dinner with my parents. We went to a place that had Italian food, and they had the olive oil to dip your bread in, and they did Parmesan cheese, like flakes were in that dipping oil. And I dip my bread in that oil, and I take one bite, and I go, this tastes exactly like 3D printer resin. The high quality Parmesan coupled with olive oil has the same flavor as 3D printer resin. I sit here and I guzzle that stuff. Actually, Dave Attell did that joke where there was a Windex bottle on the stool that the comedian has, and he was doing his act, with the microphone and everything, talking to the crowd and all that stuff. And then midway through his bit, in the middle of doing something, he unscrews the top from the Windex bottle and guzzles it, and he continues on as if nothing had happened. And that's the old blue Gatorade in the Windex bottle gag. All right, I think, I'm never going to get it all unless I put it in a bath, unless I put it in a sonic bath, because sonic bath can work these little bits of flux clear, and clean them off and make it look brand new. If I really wanted to, I could sit here and scrub this thing all day, and maybe I am stalling a little bit by scrubbing. But essentially, that's how you get the circuit board to look new after you've done the whole project. Now, it doesn't look like there was ever a trace here. Maybe. I'm worried that there was a trace. Well, no, there would be residue left from the trace. You'd be able to see, yeah, there was never anything on this pad. That's why the pad was so easy to remove, is it didn't have anything else holding it down. So this is coming from these pins here. The power plug is this IDC, and on the stripe, these pins here, you have minus. Then you have ground, 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 and they go ground, ground, ground like that. And then you have positive on these two. So this is the positive, so the marking is negative. As far as I can tell, he probably put these in the right way, but then again, if the voltage regulator died the warrior's death that it died, this thing died a warrior's death. Here, check this out. He did. That thing died pretty badly in service to music. No one ever looks at PCBs except their creators. I look at PCBs. We critique PCBs all the time. I always look at PCBs. They're fascinating. Somebody put, you know, blood, sweat, and tears into their design. I want to see it. How do we check to see if these are the right direction? We need to be able to check to see. I guess the square pad is the stripe pad. So we have to look at the pads and determine which one is the... I don't want to bend this again. This thing's going to fall off. So it's hard to see, so I'll remove a little bit of solder from it. I think it's these bottom pads here, but again, this is Julian's work, and I don't want to do too much rework on it because he put his effort into it. I do want to check over that his capacitors are not in the opposite directions. Just make sure there's no shorts on it too. All right, so that's the square pad. Same with the one next to it. And those are correct. Those two are correct. So we'll put a little solder back down on that. It's solder and aluminum because I am an American and I say Z instead of Z. I do not add syllables to everything like the Brits. If you really want to be accurate, you can also call it aluminum, but I also call it soccer instead of football because that's what you guys called it when you introduced us to it. You guys also had Southern accents back then. So this one should be facing away, and it is. Okay, so those are correct. These are 1% resistors. The resistors on the board are, yes, that's why they are that obnoxious blue. The sort of, not even Swedish blue, they're just obnoxious. And they have color bands on them, which I dislike so strongly. I love my surface mount components. Surface mount components are labeled. They all have labels in language, and you can understand them, and you can see what the value is. Here, I'm just looking around trying to find something surface mount. Sure, they may be kind of tiny, but this is easier to solder than this. Fight me IRL. I will stand by this opinion until I am bones in the ground and even beyond then. This is easier to solder because you just slide it onto the pad and then solder the other one. And then when you come in and observe it, you say, oh, that one is 10K because it's 1 0 with 3 zeros after it. Easy peasy lemon squeezy. Now, when you get into the smaller surface mount sizes, that's just torture. That's just torture. That's just some circuit designer going, neener, neener, you can't even see what the value is or even see what the resistor looks like because it's so tiny that it's... Anyway, this is probably the minimum size that the smallest size that I would ever use in surface mount. You can see that even the silk screen can't kind of keep up with this. It's a little blurry. These pads are extremely generous. They go way over the edge. If you're really trying to conserve space, I would still stay with this size of surface mount with this size of pad because I'm not making like a professional device. I want to make something that's repairable by human beings. If I'm a big corporation, I'm just throwing away boards. Fine, tighten it all up and use the small surface mount size. But I am but a man, and I enjoy soldering stuff. And if you have a little bit of magnification, these are nothing. They are way easier than having to push down on a resistor and solder it from one side of the board or the other, and blah blah blah. I could go on for days about that. Okay, so those three caps are in the correct direction. So I guess that means we are good to go for soldering this thing in. I don't see any other reason why this thing would be broken or why that voltage regulator would have exploded, which is kind of worrisome to me. I don't see any like shorts or outward damage, and all the soldering is decent enough. Although he could have used a little bit more solder on that one pad. How fucking dare you? I'm here trying to run a professional operation and you can't even put solder on your pads? This is fine. This would still conduct. Really, I shouldn't be adding the solder to the iron itself. What I should be doing is heating up the pad and then adding the solder to the other side of the pad. And that way, you give it a chance to wick around and look like it's wet, or W-H-E-T, wetted, versus W-E-T, wet. I'm using both words in a sentence. It's horrible. It's completely indecipherable, even by purveyors of the English language, natural purveyors of the English language. It's confusing. I think I need just a little bit of flux, so I'm going to add just a little bit of solder. You can see that flux just spreads out. I don't want to, ooh, careful. Okay, so that situation, you guys saw that pin move a little bit. So what I'm going to do is I'm actually going to plug a power plug into this if I'm doing that kind of rework. I don't have like a spare plug sitting around. I'll just plug this in from the other side here. The other thing we have to verify is that the power plug is in the right direction. Let's just move that in with, that means I'm going to poke stuff with the soldering iron. Okay, so the LM78L05, right? It's rattling around somewhere on the bottom of the desk here. Simplest language? No, 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 no. I don't avoid the college words here. We talk big words, and I'm very American, and I've got a very American accent, and I'm very Northeastern. Very Philly, well, not really Philly, a little bit Philly. I don't speak with like a Delco accent. All right, I'm just closing old windows for things that we don't need. I don't need any of this. Let's just get rid of it all. We'll keep up the Etsy pages. All right, so 78L05. The 7805 is a famous voltage regulator, and I say famous because it's one of the things that anybody who knows anyone who knows electronics will know about this, and even people who don't know electronics know about this voltage regulator. Although people who don't know the Venn diagram of people who don't know about electronics and people who know the 7805, that intersection is it's a world of anger. It's an intersection of pure hatred, because the people who don't know about electronics that have had to deal with the 7805 have had to deal with one that has failed. Generally, you don't think about this stuff unless you have one that fails. Just 3 pins, in, ground, out. But the problem that I have with the 7805 is that it regulates by relegating the extra current to heat. It can be a fairly steamy chip if the chips are down, so to speak. So 78L05, tons of data sheets. The L, I believe, designates this what is that? It's the TO220. It's not it's not a dip. What is it again? What is that package? Where's this data sheet? I thought I clicked on a data sheet. Product change, temporary special, general announcement. I'm just going to do 7805 data sheet. Datenblatt. There you go. TO92, that's what it is. L is for low current. Yeah, it's L as in low current because it doesn't have a heat dissipating tab on it. They can't get a lot of current out of it. Yeah, SOT23. SOT23 is the surface mount. That's why the S is in there. Surface mount, OT. I don't. It means something. OC and I. What the? In, common, out. It's in, ground, out. IGO. What the? Okay, so the input, and notice, oh, comma, yeah. So notice how they do a three-dimensional diagram, because am I looking at this from the top or the bottom? I don't know. It's so annoying. I guess we're looking through the package on that one. All right, so this device installs on this side of the board, which makes output up here common, and then input is down there. And you can see by tracing it out, it goes over to that one, and then that one goes over to the positive pin. Okay, so that looks to be correct. 5 volts is coming out up here. All right, so we can put all our parts in now. We got a little idea of how this thing is functioning. How it's getting its power. Its source of power. So 7805, drop it in. And then what I'm going to do is, instead of bending the pins to hold it on, instead of using tape, I am just going to put my finger on it and we'll solder it from up here at first. So all I need to do is position my solder so that it's close enough that I can grab it with 2 fingers like this. And now I can operate my solder like this. I can hold my component in place, and then I can use the iron on the other hand. This is just one of those stupid little techniques that I do in order to initially install stuff. So heat the pad, get that solder on there. That's enough to hold it in place. Now we can actually go in and solder the device. Now, sometimes you could burn yourself by doing that. Many of my techniques involve just holding my hand in place while trying to ignore pain. You can see there, you know, I just naturally did a perfect job soldering. We'll be able to see the soldering job with these other two. This is sort of like the basics of the basics. How do you solder things together? And it turns out all of the places that you read how to solder, they're not trying to trick you in any way. Their techniques are exactly how you're supposed to do it. There's a couple different properties to the soldering iron, a couple different properties to solder, what you're looking for, how things should look, what a cold weld looks like, a cold solder joint looks like. These are things that you kind of get used to over time. I'm trying to get this in focus, but it's like kind of really annoying. Also kind of really annoying. That's a little better. Okay. And then I'm blocking my own light, unfortunately. But I'm looking at this at the same picture that you're looking at. We're a little close. It's a little claustrophobic. Magnification helps. Since cross-stitching is so popular, you can buy a cross-stitching headset that has a headlamp on it, and you put different plastic lenses on in order to give you magnification. That thing is amazing. I bought one during an Amazon Deals Day, and it works so well when working on electronics. Having a headlamp, a source of light that's coming directly from your forehead, is really, really useful because you can get these lush, beautiful views of exactly what's going on. And, you know, it's always good to have a magnifier, so you might as well just buy one anyway. Is this thing crooked? Feels like it's crooked. Guess it's okay. It is a little crooked. Oh, yeah, that's sideways as hail. Hold on a minute. I'm going to correct it while we still can. So all I need to do is heat up the one pad, and I can just make this thing stick straight up. There we go. That's better. Okay. So what's your opinion on this ESD gloves? Should one use them when soldering and manipulating components? Not necessary. The desk here is grounded, and I touch the desk and stuff. I've not really ever static discharged directly into a chip. I don't think that's a thing. Depends on where you are. If you're in fucking like Arizona, yeah, you might want to mitigate a little bit of that static electricity. It's here in the Northeast. I mean, it does get pretty staticky, but I don't know. I've just never really needed one. It's just never really benefited me in any way. The electronics will be able to stand a couple static shocks. It's really a statistical thing. When you static shock something, inside of like your chip, there's going to be your actual silicon die, D-Y-E? No, dielectric, D-I-E. So your die is going to be sitting on top of a piece of metal, and then that's typically ground, and then the different circuit elements of the die are going to be connected using a gold bonding wire. The gold bonding wire is cold welded. It's pressed down onto the silicon substrate in order to give you that connection. But that bond, that cold weld from the squished gold wire, the space between the gold and the silicon is where the static electricity is going to blow up some of the material there. And you have a certain number of blow-ups that can happen before it disconnects. That's what happens when a chip dies from static electricity. So it is a statistical thing. It can stand a couple from the get-go, and so when we're dealing with a lot of new electronics, I'm not too terribly concerned about static. But also, like, if it's a day where I'm snapping a lot, like if I get up and I static electricity, I'll touch the desk or something grounded before I start working on the sensitive stuff. Did my iron turn off? My iron turned off. My iron turned off. Yeah, I guess if you're manufacturing and you want everything to leave the door just right, or if you're in like a super clean room and they keep the humidity down. I just think it's a lot of bother for not a lot of benefit. All right, so that's it, right? That's soldering. You just heat up the pad, and then you apply the solder to that pad. You don't need too much. With through hole, you probably want to hold the heat just a little bit longer than you think, just so that it can propagate all the way to the other side. It doesn't need to, but it looks good if it does. So I'm just going to add a tiny little bit of extra solder to each of these and hold the heat just a little longer than I think I should. Just like that, and you'll see it kind of retract as it sort of wets the other side. I don't think it retracted, or maybe it did it very quickly. Hold that heat there a little longer than you think. And it doesn't take a lot of solder. You're very careful with the amount of solder that you add. You don't need to do a lot. So now the new voltage regulator is installed. I could take my flush cutters, and just snip these off. I'm going to put my finger on it just so it doesn't fly across the room. Are you able to solder the straight headers? In my case, I always put heat too long and melt the plastic. Here is a big tip. And just the, no, I'm not going to make that joke. Everybody makes that joke. Everybody knows that joke, just the tip, only for a minute. Yeah, blah, 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 blah. Here's the trick with square headers. That's the trick. It's a socket. Have a socket. Have a header socket. That's all you need. Because when you solder these on, the plastic that they use on this stuff melts. So when you're soldering, the pin will start to wander. It won't wander if it's plugged into a set of female headers. So that I can solder down, and I can apply plenty of heat for plenty of time. And I don't ruin the thing. That works for all kinds of other stuff too. Have something there to wick the heat a little bit and hold everything in position. That's the trick with that stuff. Yep. And like, for instance, I'll use the breadboard too, the solderless breadboard, to help with stuff like that. If I have to solder wires to headers, I'll put them in here first. Okay, the capacitors. What the hell They were like 3 different capacitors. I don't know which ones are which. Some of them have a lot of solder on them. Here's the 2 that we removed, and then there's one more that I removed. Where did that one go? It's rattling around somewhere. Uh-oh. I'm missing the capacitor. Where did that one go? Well, I got a whole bin full of capacitors, so maybe we should just find our own. I'll just replace the ones that I pulled out. Yeah, I had that other cap, but it was rattling around the desk, and I didn't do anything to keep it in place, so it found its own spot in the world without us. It's not over there. Okay, it's not over there. Under this, some of this stuff. Come on, Cap. I know you're in here. Well, maybe it's better just to be safe that we don't put the same capacitors back down. Yeah, it's in the cat dimension. We still don't know what blew up the voltage regulator, which has me a little bit concerned. Okay, well, we'll have to put our own in. Self-yeeting caps. Yeah, it yoded. $47, $47, and $100. 2 $47s and a 1 hundo. They have to be relatively small ones. If they were surface mount, they would fit. 25s. Really? 25 volts? You're from minus to plus is 24 volts. These are, of course, going to be dealing in 12 volts, but it's still, I feel like it's a space where you'd want something like 35 volts. just in case, because these are, well, I guess they're assuming that the power that's going into this thing is going to be pretty well regulated. I don't know if I'm going to be able to find 47. So we might just put the original one back in. Wait, was this one in the wrong spot? I don't think putting the wrong capacitor in the wrong spot would do anything. 25 volt, 100U. And this is 4.7. 47? 47, 100U. Of course, we aren't married to those values. We could probably put different values in there and it wouldn't really suffer for it. But we need to find another 47, 25 volts. One off. That's not right. Eight. I probably used all of the 47s, to be fair. 3. 3.3. Again, maybe we should just take them out of the bin, and that way I know that I've already checked. This bin of caps is getting more disorganized as I start using them. 6.8. Got this one with the tiny little leads. 100 UF, 10 volts. That would blow up if I put it into this circuit. 125. Okay, so we'll just replace it then. We'll replace this one. You go in the garbage now. Probably not that necessary for me to replace the caps. I'm just a little concerned that they were the reason the voltage regulator blew up, and I didn't check to see what direction they were in. I guess putting a capacitor in the wrong direction, I don't think that would kill the voltage regulator, though. Especially as hard as this voltage regulator failed. That thing fucking looks like it was on fire. I mean, a significant amount, 6.850 volt, a significant amount of the substrate was gone. Oh, hell no. No, I just have vague memories of where I put stuff. I got a mental map of where everything is and vaguely what I have. Yeah, spreadsheets are too much work, and you got to keep maintaining them. 100. 10. I'm guessing the 47s are used in other stuff. 47, 50 volts. This'll do in a pinch. 20. I mean, the other thing I could do is look around for the capacitor and see if I don't have it, if it's not on the floor. Let me just look on the floor real quick in a very dignified move. Shuffle around on the floor a little bit, see if I got it down here. I don't immediately see it, so I don't know. And by all means, it could still be on the desk. Yeah, all right, so it's not there. It may have just made its way under stuff. This is it. 47U25V. Why is it totally different from the other one? 4725. This one's 4725. I worked as a component engineer. That was my whole job. Oh, man. Yeah, when people ask what I do, if I don't want to tell them what I do, because this is what I do, and this is not something that I want to explain to people all the time, I tell them, yeah, I just do engineering and consulting. It's a lot of spreadsheets. And then they stop asking me what I do for a living. They don't ask you again. It's great. They don't want to hear about spreadsheets. What's up, Olafab? 47. I'm looking for one that like matches that one. Because having two weird looking, like totally different capacitors, it bugs me. You don't want to explain, you let the magic smoke out? What is Twitch? My son said something about Twitch. I don't know what it is. Can you explain it to me? No, I can't. Like public TV. 4.7. Nope. See, this one's a 47, but it's a 50 volt, which makes it look like the other cap. If I can find another 47, I guess I'll put the 50 volts in, but oh, this is another one. Okay. Well, I said that, but I'm going to go back on my word very quickly. Big blocks of metal into smaller blocks of metal. Yeah. I turned metal into dust that I then inhale. And the metal that's left is in the right shape. 4725, and it's a yellow cap or a gold cap. So we can use that one now. So we'll use the two golds and the big boy over here, and I don't need these two big boys. Real, yeah. His lungs are protected by the metal cladding. Yeah, it's like when you cover something in rust in order to prevent it from rusting. It's a thing. It's a real thing. They really do that. All right, light back in here. Get the camera back in here. We can go back to the micro view, I guess. This is very not microscope kind of stuff, but now why were we soldering these on the opposite side? I guess that's just where they're supposed to go. So the two in the periphery are, okay, so the big guy goes there. Big guy is this one. And we make sure to put them in backwards so this thing blows up. Yeah, sorry. We were being very dryly sarcastic with all that stuff we were saying. Don't put the metal in the lungs. Don't do it. From our understanding of the way that the schematic symbol works, we are putting the negative lead through the marked square pin, or square pad, square via. So this goes all the way down to the bottom. I'm going to just get that all the way down there. All the way down to the bottom. And then I don't like having the leads bent in order to keep this thing up. This is a personal preference kind of thing. But what I'm going to do is I'm going to keep my finger on this and then do that same technique. Actually, I've got it on the opposite direction. So maybe I can just lean the solder up against the pad that I'm using. Actually, here, I can do this, and then I can pinch with my thumb. So you guys can see the techniques that I'm using to do this. That's why I have the other cameras up. So I apply heat to the pad and the pin, a little bit of pressure, just a little. It's like pressing a pencil down, hard enough to break the lead. Actually, no, it might take a lot of extra pressure to break the lead. So you just, I don't know, whatever, just press a little tiny bit. And then I just hold that heat there for longer than I think. I go to the next one. Watch your iron. You know, you got to keep it clear of the other stuff in the circuit. That's going to heat up the can very quickly. I'm going to get my finger out of there. And then just apply it the opposite side, just a little bit of solder. And then you wait. That's probably good enough. I don't think that made it to the other side of the board. No, please. Goes in the square hole. Okay, and then flush cutters. Try to maneuver these in there. Use my finger to keep this thing from flying out and shorting out other electronics. I have yet to have a clipped lead fly out in such a manner as to break something else, but it is a very, very strong possibility of happening. Stripe goes on the marked pin, like so. You can see Julian's clipped leads are quite different from mine. Okay, actually a different finger, not my index finger. Keep having to flip it. Flip it! Flip it! So put this one here. That's going to be very awkward, so I'll probably have to do this way. And then bend my solder so that it can actually get there. And then, soldering iron cable is getting caught on stuff. So hold that up and over, and then I just come in here without touching any of this plastic. Remember, the plastic's going to melt very easily, so you just want to keep that iron away. You got to come in from weird angles. All right, that one's held on, and now we can do the other one, which has long leads because it's the new one. And we'll drop that sucker in. We're giving Julian the high quality capacitors. These are better if they're in an audio path, not on whatever the hell these are doing. These are just inrush limiters as well as voltage. They're sort of providing those little jerks in current that the circuit might require to function. And if the supply drops out for any weird reason, like noise or whatever, they can provide that extra current to your circuit and smooth over the bumps. You got to burn each finger in turn. You know, we have a 666 degree Fahrenheit iron. Heat will happen. So I'm coming in from that high angle again because the thing that's holding on to this integrated circuit here, the thing that it's plugged into, is actually made out of cheap plastic and will melt at the drop of a hat. So I need to keep the iron away from it. We come in from a high angle, go right to that pad, right from the lead and the pad. We're heating up at the same time. Sometimes it helps to just tap the solder to the iron tip, and that releases the rosin core flux, and it releases, releases a little bit of solder, and it releases a little bit of that rosin core flux, and so the solder is going to flow onto the tip of the iron and help provide a better interface for heat transfer. So if you have trouble, if you're holding it here and nothing's happening, then sometimes you just barely tap the tip with the bit of solder, and it'll help everything else flow. Okay, so clip the leads. We've cleaned this board up, made it look a little bit nicer, although there's still a lot of residue on the back. And we've repaired the area of the circuit that exploded. We don't know why this part of the circuit exploded, but we checked over the other capacitors that weren't ceramic, because ceramic capacitors don't have poles. We don't care about that. We checked the other capacitors in the circuit. They seem to be okay. So if I plug this in, by all means, this should not explode. I really want to clip the leads that Julian left on, like some of the flying leads, but I'm not going to do it. This is his circuit, not my circuit. I don't see any dangers of shorts anywhere on this thing. The IC is plugged in the right direction. Everything else looks pretty standard. He put this together himself, and I think he did a decent job of it. I really do. I think he did just fine. We don't need to go back and make it into a bother circuit. A bother circuit would look 10 times more professional. This looks like something that I would have made in high school. But Julian is learning, and he's doing a great job of it too. I see a lot of good. I see a lot of good. A lot of stuff I like going on here. It's a very simple circuit. Let's observe the other one. Does the board have protections? No. Just like classic synthesizer crap where they have like no protection on the circuit. I would put diodes on all of my designs. But these guys don't have to do that, and sometimes they don't. And maybe it's for cost savings. I don't know. Just flowing that over because it looked a little weird. You don't need that much flux. Flux is just kind of gross, greasy. Greasy and gross. You don't need that in your life. A little bit goes a long way. I'm looking for cold joints. I'm looking for incomplete soldering. I wish I could do something about these leads that are flying up like that, but it's not my business to correct that. This goes back to Julian when he comes over here this weekend. Because apparently, I think something else of his is broken. I need to fix it again. Wait, why was he coming over? I don't remember. What is this stuff? I think that's the cotton. It's not going away. Getting further singed. That one looks okay. That's fine. Okay. What is this? What is this? That's nothing. That's good. That looks fine. It's the willow hair insulation. No, I think it's the cotton from the cotton swabs. I do see, like, oh no, that's still more cotton. That's not willow hair. It happens, though. We see willow hair in places where we really shouldn't. So what I'm doing here when I do this, I'm sweeping the soldering iron on the circuit board. I'm just sweeping it across the leads because sometimes there's like a flat piece of solder that could make a short between the two terminals. So you can kind of scrape it with the iron, and the iron's going to bring with it heat that'll remove the solder, and then you can also heat up the lead so that the surface tension pulls all the solder into that lead. That's sort of what I'm doing here. Is this way one of the ways we check to see if there are shorts between components. I've seen circuits that I can't tell you what they are, not allowed to, but I've seen scrapes that have scraped through the solder mask and put a trough in the board itself. See, this is where I worry about cold joints. Although it does appear to be flowing over everything, there's way too much solder here. I'm going to heat it up and maybe it'll retract a little bit. It's still bubbling. Why is it bubbling so much? Jeez. I don't want to overheat the component. See, that looks a little better. I don't even know what that is. Well, the solder looks fine on everything. Really nothing to be desired here. Yeah, I don't see anything that I don't like. None of it strikes me as being bad. Just blow this one a little bit. Come on, buddy. Blah 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 blah. All right, all right. Well, I guess we can test the circuit out and see if it blows up again. I wonder if he plugged it in backwards. Maybe that's what it is. I have extremely dry mouth. It's one of the symptoms of hyperglycemia, and I had a big lunch. It was a rare opportunity to have a large lunch, and I knew what I was doing, but do you have a usage history for the synth? This is a delay module, and no, I don't. But you're just getting here, Mahalo. Here, check this out. This is one of the most righteous fucking deaths that I've ever seen. Oops, hold on. Where's my micro? I think I've moved my scenes without realizing it. For some reason they're hard to find lately. This thing died a warrior's death. This is a 7805, 78L05, a low current 7805 and a TO92 package. Or what was formerly a TO92 package. This thing died. And so the 7805 dumps all excess current into heat. And this one dumped it into heat so hard that it created some kind of a gas that had to escape the packaging. And so pop goes the weasel. The silicon, yeah, the silicon's exposed. We can get, I guess, a closer look at that a little later on, but this thing died a heavy metal death. Like, holy shit. So I don't know. I mean, unless the caps were in backwards, but I don't think backwards capacitors is going to cause that big of a failure. And the circuit is so simple. I mean, it's basically just power comes in, goes into the capacitors. There's a capacitor on the input and the output. There's a big one on the output. And then there's 2 capacitors to ground. Where does that one connect? That one's for this chip. So this one is for the chip, for I guess just a larger filter for the chip. But we have a 4.7 on the input, and then we have a 1000 on the output. 100 rather on the output. 4.7 in, 100 out, both connected to ground with these mad traces. Ground is there, ground is there, ground is there. Ground is on the square pin. The square pin goes into the square hole. It gets the stripe, stripe, stripe. Stripe, stripe, stripe. Okay, so yeah, everything's correct over there. So if one of these was in backwards, I guess that might have been the smoking gun. You can tell by the way that I check, double check, and redouble check, and then I check. Even though I know I checked, I check again. Right? That's how I operate, and that's how I avoid that kind of thing from happening. Let's get this one seated a little bit more. All these double checks are because I've made the same mistake many, many different times. So when you're building a kit, go back, check to make sure that the caps are all in the right direction. Make sure the transistors are installed correctly. Make sure, go and check those things that you don't think you need to check again. Because sometimes you blow up a voltage regulator. I really wish my dog would stop barking. She's very cute, and it's a very cute little bark she does, but it's also very distracting when I'm streaming. You're boo. You should be napping. It's a doggy napping time. Okay, so I have an odd feeling that Julian plugged it in backwards in spite of the keyway connector. I know that for some reason these guys are prone to doing that. What we have here is a module testing stand that I built. I kind of wish Julian brought me the front panel for this thing, because it's kind of annoying to test things without front panels on this stand. It's just like, it doesn't really work. So on the stand, I have various waveforms coming out. This whole business is going to be retooled, and it'll actually be a module tester machine. I don't know how complicated the module tester machine is going to be. I need to throw something up on the screen, build the circuit, put it all together, and then it's a software problem. So I need a whole huge piece of software in order to do all the testing and get this display to work properly. So I don't know if I'm going to do that. The important part is we have waveforms that we can put through the delay and we can observe coming out of this thing. So for right now, the initial test after repairing a device is to just give it power. I have the advantage of having thermal imaging to see whether or not components get hot. So when I turn this on, I want to observe what gets hot. 7805, that's going to get hot. We're going to see how hot it gets. It shouldn't totally run away. We're also going to observe the amount of milliamps going into the circuit. Nothing uses 5 volts in here yet. The test stand is going to use 5 volts for the screen, but I have this here anyway, just in case I get a device that uses all of that stuff. Typically, nothing uses 5 volts. It's all plus minus 12 volts. So we're going to observe here that this doesn't go over probably 100 milliamps. Anywhere over 100 milliamps is probably going to be like an insane amount of current for a modular device to use. So 3, 2, 1, go. Very little current, nothing. Heat. A little bit of heat in the 7805, but it's not a huge amount. This isn't a debilitating amount. Vibe coding works quite all right for embedded. I have the code to run the channels. The thing is, when this thing is actually a module testing module, part of the circuit is able to check on the other part of the circuit. So it can actually like check its own voltage levels and tune itself. And so I have to program all of that. This is still getting hot. But if it immediately heated up, I would have turned this thing off. But yeah, I have to program in the routines for it to test and calibrate itself. I have to then program in the different modes. I have 6 I/O that I need to be assignable from the front panel. And so I think at first what I'm going to do is just program it to output waveforms and to like check waveforms. But I need to program in the various frequencies and voltage levels. I need a way to measure frequency into the I2S audio system. Paul Staffergan has a lot of really good tools for doing that. So, I mean, I guess I could do that. I guess I could take a look at those tools, but I'm going to get another seltzer. My throat is dry, and I am thirsty. And this is fruit punch. No, this isn't fruit punch. Sorry. Quoting Venture Brothers. I started to watch through Venture Brothers. All right, so what does this thing do? I have to turn on my oscilloscope. My oscilloscope. I really should have, and maybe I could do this someday, is just have BNC connectors in the back of a testing thing. So I can plug them in and have them on, like, I don't know, put like a row of pins at the top. So I plug in BNC to the back of this thing, and then I can, that's a lot of routing. That's a lot of routing. So I bought this oscilloscope. It was like $1,000. I bought it because I did another lap around the sun, right? It was a milestone lap around the sun. This oscilloscope has a super duper logic analyzer thing on it, and it's got all these really great features. It's touchscreen, and finally, instead of just recording the oscilloscope with the camera, I can have an overlay on the screen that shows the oscilloscope. But bother, you say, isn't there some kind of a catch, like a monkey's paw kind of thing? No, there's no catch about this oscilloscope. There's absolutely nothing wrong with it. I'm going to turn it on really quick. And we can just start using it right away. Let me turn on the overlay so that we can actually see it up on the camera. Where is that overlay? That one is right. No, it's road. That's audio. Scope. I got to find it in my thing. Yeah, here it is. Dude. That should be coming up. There it is. So we can get it just right up on the display there. And that's 60 frames a second. It's pretty cool. Also, if you had that scope remotely, you can access it through the intranet. You can access it through the device's IP or whatever. And change settings on it. Because it's a touchscreen interface, you can click on the screen and actually affect stuff. Pretty cool. All right, so our ins and outs. I would like to put a 120 millimeter fan on the back of it. I think I want to do that. We put a quiet fan in there, but it runs about 10 degrees above where it used to. I kind of want the longevity of my device though, so we should probably put like a whole box computer fan on the back. I have one that I can use. Okay, so we're looking at Dive Bomb. There we go. Time, effect, feedback, distract, in level. So in CV in Vactrol time. What? Effect only and out. All right, so how do we test this? Well, really, we should be giving it an audio waveform in. I don't have an audio waveform to give it in. So what I will do is I will give it an input that is just a wave, just a very slow for it wave. I think it's a C note is what I used for these outputs. I guess they are audio. They are audio time, the C note. So we'll give a C note in. For a CV, I don't have right now. Julian is borrowing my what do you call it? Ornamentations module. The ornamentations module I could have used to make a CV. I should probably build something that's just a plus minus 10 volt CV maker so I can have a knob that makes a CV, but I don't have that right now. So let's just see what this thing is able to produce. So, let's see. This is my observations here. I can plug that into here for one channel. I can plug my other channel into the other one. Now I've split the oscilloscope into multiple different things so that I can take a waveform. I gotta find all of the wires that I have on the desk. Take one of my waveforms over here. Take this one, put that in there. We get nothing. Good day to you, sir. Is that not making a good connection? There we go. All right, so there's a waveform. Let's reconfigure. We were in mixer mode for this, so everything was at lower voltages. This the USB for this is still getting in the way. Everybody power down. Bring this over here. Kind of scooch it behind stuff. I still need to be able to reach things. Yeah, maybe they want you to turn it on once and just leave it alone. I wonder if that's like a typical use case for that sort of thing. All right, and then our waveform should come back. Oh, it didn't like the inrush current. There you go. That screen used to work. I don't know why it doesn't work anymore. Hey, it should be working. Nope, screen just doesn't work. It doesn't like it. Where did my waveform go? I hit the reset button and it scared it. Ugh. Okay, everybody power off. This device is a little bit moody. Yeah, it's I2S, which is like I2C, but it's meant for sound. And you can run multiple channels out of a Teensy using the Teensy audio tools. It's pretty cool, actually. Those audio tools are very neat. Are we on channel 1? I think we're on channel 1, so let's just put our initial wave into channel 1. There we go. That's not syncing it up either. What are we triggering on? Channel 1, bring that down. There. And then our trigger. What are our trigger settings? Trigger menu. Channel 4. Channel 1. All right. Back to triggering on channel 1. Nice and stable. So if we put this square wave into, I need more plugs. Where are my wires? My wires are all the way over here. They're like hiding out. This is mono, this one's stereo. All right. So we want to take that same waveform. We can observe it on the output. Make sure that's working. Why isn't that outputting? We should be seeing the same exact freaking waveform. What are you doing? What the hell are you doing? Wait, we're not even seeing it on the input. What's going on here? Is this thing being moody? Hold on. Someone's being a jerk. Ah, it scared the shit out of me. Damn it. God. I have heart problems for you guys. Did you talk about the testing jigs power supply? Looks like you got boost converters to get plus minus 12 from USB power. No. Actually, I have. So when I bought the oscilloscope, actually a little bit before I bought the oscilloscope, I ordered a bunch of dog bones from Amazon. And instead of dog bones, I got a $75 laptop power supply. It's a USB-C power supply. It's got 2 USB-C ports and a USB 2 port on it, or 3, USB 3 or something. It's from Anchor, you know, whatever that power supply company is. And so traditionally, the best power supply goes to the oscilloscope. That's just how I run my shop. When I got this oscilloscope, I discovered that this thing just has a USB-C plug on it. and it's got its own little cheapy USB-C power supply. So that went to the super duper laptop power supply. When I was building the test rig for the modular stuff, I realized that I have this extra USB-C cable kicking around right over by my oscilloscope. And so the thought was this thing is going to work in conjunction with the USB powered oscilloscope. So why don't I put my good power supply on the modular thing? USB-C has a protocol where you can negotiate for power. And one of the powers that you can negotiate for is plus minus 15 volts. That's the input to a modular synthesizer rack. So the plus minus 15 volts comes out of that, goes into a positive regulator, a positive 12 volt regulator, positive 5 volt regulator, and a negative 12 volt regulator. And those can produce amps of power. It's actually way too much power for this setup. It could power a big modular rack if it really needed to. It's because I buy the power converters from Pololu, who has some pretty amazing, meant for robotics, power converters. Why did my whole setup stop working? Are we not outputting waveforms, or is my thing broken? There's our waveform. So if I plug this into this, why am I not seeing it? Is there a cold solder joint on this thing? I haven't really tested this breakout thing. That should be working. What the fuck, man? Dude. Yeah. You guys ever do this on a camping trip? You guys ever try that? A lot of fun. All right, so that works too. So why doesn't my breakout work? Did I not solder something? We saw it working a minute ago. I saw it working. Did I wire it wrong? What's going on here? This is embarrassing. Oh, now you work. Okay. Some PD chargers support plus minus 15. It's not the quick charge specs. It's a spec somebody else put into it. Oh. Well, this power supply has no problem doing it. And there's some modular synthesizer stuff that is USB-C now. There's some power supplies. Now these are all tangled. So why? Okay, so one specific, this is down to the thing that I built. Once again, if you build all of your own test equipment, you have no one else to blame for it not working properly. Okay, that's on channel 2. Channel 1 on top, channel 2 down below. Okay, that works. So then I can plug this into here. Both channels should be a square wave. I think I bumped this and it didn't like that. Is that in a socket? Why is that wiggly? Oh, that's in a socket. Okay. See, these are just audio waveforms representing the maximum signal. There we go. 2 square waves. All right, so I got to look at the back of this one and kind of fix it up. Let's do that real quick. I need reliable test equipment. Problem is the 3D printed front panel needs a circuit board to go the length. Otherwise, it's too weak and the whole thing will bow in the middle. And so I think that's what's happening a little bit. And that in conjunction with cold solder joints is probably hurting it quite a lot. This setup is also very moody. It does not like to cooperate. So I think I just need to flow over solder on some of these. PSU I use for Amigas is USB-C and it uses 15 volt out of 18 PD3 quick chargers that I have. Just 2 I have supported it. Huh. Yeah, certain things I guess just don't support it. I didn't know that, but Like, the solder's there. It might be shorting out in some spots. Let's make sure it's not shorted to ground. My iron cable is wrapped up in everything. Jeez. Very annoying. Well, yeah, stiffness, especially with PETG, is tough to achieve. I'm trying to bend that wire so that it doesn't short with the pin next to it. That could have been the problem. Weird that some of them just didn't work at all. That's the switch pin, so that's not doing anything in this setup. Nah, I'm not going to continuity test it. I'm just going to make sure that nothing is a cold solder joint. It's always cold in solder joint. I kind of hastily made this. So, damn it, I hate it when I do that. These things are so small that sometimes my middle finger creeps up on the thing that I'm soldering, and it ends up here, sort of in the danger zone, and then it ends up touching the iron barrel, which is what just happened. So I got another burn on that finger. Just another burn. That is not making contact. It looks very, very close, but it's not. Fine. This is a kind of a hasty thing, but I needed to have the ability to plug things in the way that I am right now. Connecting hills are all sharing a ground. My smart coworker was using a gas iron today. Some quick fixes without thinking. With screwdrivers and stuff. He put it in his pocket. Oh, that's terrible. Be careful with the gas irons because they get real hot. I always use the gas iron because it's able to put lots and lots of energy into that tip, and so you can solder stuff that's like real thick. Man, putting it in the pocket, that's almost as bad as when I was holding the iron in my mouth and I went to grab it, but I forgot which side the cable was on, and so I chose poorly, and I just basically poked the soldering iron directly into the middle of my palm. I had a little divot where I could hide drugs. Burned a hole in his pocket, and it flipped down his leg. Oh, what a terrible thing to do with the soldering iron. Making that mistake again. You guys gonna have to take like a training course now? I have no reason to believe this thing shouldn't work perfectly. Like, how simple is this? And yet, somehow I still can't get it to work. It really fills you with confidence when something that is literally a bus bar doesn't work on your watch. Feeling good about oh bother right now. I keep thinking that you're constantly using the duck emote, but it's part of your name, and it comes through every time. I'm like, man, this guy loves that duck emote. No, that's what he is. What they is. I don't really think this is totally necessary, but I'm doing it just because, I don't know, something's weird about this. I'm just checking to make sure that everything under the solder is okay. I need to heat that pin up. I just do that because It's possible that little bubbles of solder are on the other side, and maybe those are what's causing trouble. That could actually be it. If there's like a whole bubble of solder on the other side of this thing, then maybe it's shorting out to the, let's get the multimeter on this. Did the quick fix help? To what? We did a slow fix. So I use ohms mode because ohms mode doesn't lie to you. The beeper will lie to you. The beeper is bad. You guys should not be using the beeper unless you're in a rare instance where you're unable to observe the screen of the multimeter. So let's test some ohms here. We'll go to the microscope again. I can see what I'm doing a little better like this. Although I would like some room to move around. There's too much stuff. Too much stuff. I'm getting inundated with things. Nope, do not trust the beeper. It will lie to you through its teeth. Oh, that's supposed to be connected when nothing's plugged in. Yep, okay, short to ground, huh? Ah, I think what's happening is the solder is bubbling on the other side of this PCB. So, oh boy, how do I get over this problem? We shorted power to ground, huh? Oh, yeah, look at that. Actually, it could just be because of the shape of the connector. Huh. Okay. Well, that changes the story a little bit, doesn't it? So I probably should have put down, yeah, see, it's shorting across there. And that one is on its own. No, that one's doing the same. So that one is shorting to here and here. So I probably should have used shielded wire, I guess, to build this thing. And now I've got to rip up those grounds because they're shorting to the pin of this. The ground won't short because the ground is just a singular pin. But this one and this one are a bar. So when I plug a signal into this, it'll push this out of the way. Or no, it'll push this out of the way of this. So it's okay if this is ground. Because, no, because then that'll be short to ground. So both of these need to be isolated. Both of them need to be isolated. You use another rack of holes, not use this one. I don't have another rack of, I don't know what you mean. Not sure what you mean. So this is fundamental to the to the plugs. Here, do I have a Donkey Kong connector sitting out somewhere? I don't. I can't show it. Donkey Kong connector is fairly simple design, but it's got a sort of like flat piece of metal in it. When I put it up against this thing, it is, as you can see right here, it's butted up against this hole. And so if I solder on top of it, that's going to just solder directly to that hole. So these are, unfortunately, I have to go back to the drawing board on this one and either put down a piece of Captain tape over that or use a shielded wire and do the little hopscotch thing with the wire. I hate doing the hopscotch with the wire, so I'm probably going to opt to desolder this and put a piece of Captain tape on every single instance. Oh boy. Perf board PCB you're trying to repair, but if you don't have another one, you're stuck. I have more perf board. I have plenty more perf board. But I think this is going to involve a hands-on repair. I mean, in the immediate, what I could probably do, let me try this. I can solder suck the hole and put the pair of tweezers in there so that it lifts the wire up. and avoids shorting out against it. We'll have to keep our eye out on the other ones too, but just get that in something that'll hold it. Drinking seltzer out of a can is a little weird. I'm used to things in cans having flavor. All right, so what are happening? When nothing is plugged in, okay, so we've got 3 plugs on this thing, right? These are mono connectors. They're mono connectors, so we have 3 plugs, and you can see a little lump in there. And that little lump is actually what's going to contact the notch in the front of this tip and ring. Tip, ring. And TRS is the stereo version of the TS plug. That looks like, hold on, I have one. It's, where the fuck, where is it? TRS is your typical stereo plug that they are, for some reason, getting rid of. It's a very nice plug. It works very well. A lot of cycles on it, and it's a beautiful little bit of engineering. But apparently, everything has to be Bluetooth now. But still, tip, ring, shield, right? So that's that kind of plug. It's usually used in audio, and it can have any of a number of complicated things that it yeah. Anyway, whatever. When you plug that plug in, the typical design of your socket is that you have switches that are activated. Because if you have something like a very simple stereo, you would have that audio line go through that jack and out to a speaker, so that when you plug in your headphones, it would disconnect the 2 lines that would route it out to the speaker, and so it would only go to your headphones then. And so these do a mono version of that. Inside of them, there is that little loop that gets caught on the very tip of this thing, and in doing so, it moves it out of the way of a contact. So what happens is, it's this contact here, the one that I didn't, I need a pointer. When you plug a headphone plug in, or sorry, before you plug in a headphone, this contact is connected to this contact. When you plug the headphones in, this is isolated, this one is the tip. As I have it right now, because of the design of the plug, that contact here goes to all the way. It has a bar, a metal bar. You can see it right here. The metal bar that's in there is contacting here and here. And so what we've done is we have created, this thing is connected to ground, this is connected to ground. So if I were to plug in somewhere else, it would be connected to ground. So what I need to do to isolate it is take this one, and I need to poke something under it so that it separates that wire from that pad. And really what I should do is put something on that pad to insulate it out, or remove the pad somehow. Is it going to be a problem over here too? This might still be connected to here because of that bar. It's not that big of a deal down here if that connects, but this one might be butted up against it and making a connection. These are vias. Vias go through the board. They're plated through. If this were a one-sided board, I might not even be having this problem if I had one-sided PCB material. So I guess what I'm going to do is desolder this, stick the tweezers in there, and that'll kind of lift it up above that pad. It's not a permanent solution, but it's something that I can do now that'll help kind of get this thing to work. Maybe I could even sneak a piece of tape in if I feel frisky. But I'll do the air desoldering on it. Man, that sucks. I didn't know that would have been a thing. I got to watch out for that in the future. Maybe that's what's killing the frequency thing. No, those are wires going directly to it. I don't think there's, maybe I'll check for that. That might be what's happening with the module tester. That's a big smoking gun. Holy shit. So now I need to heat that up and just squish my tweezers in there and just lift this a little bit. That stays soldered. And so now it's just floating above. I've just got a little floaty bridge, like an old school circuit board. like an old school circuit diagram, more like. So yeah, this one needs to be isolated too. So let's solder soak that. This one has 2 wires, so I don't know if that's really gonna. Well, we gotta go through them all. We gotta get them all isolated. Yeah, see, there's a lot in there. The simplest of fixes, and it's taken us like all day to do. So that's what happens when I explain everything as I go. All of this just to test that delay. I guess I could get out some of my old school, the BNC splitter instead and check that out and see if that'll do it. Oops, I think I just ripped off a pad somewhere. Oh no, I broke the wires apart. That's fine. I gotta get solder into there. Where's solder? There it is. Solder, soccer, solder. Get triggered. That's fully under there. Yeah. Okay. Cool. That doesn't connect. And then we got to do this one. God, there's 8 of these. Ugh. I got to do this 16 times. Wait a minute. Hold on. Think. If I'm isolating the ground from all of these, it doesn't matter if that stays connected to here when it plugs in. That one will be making a connection. Yeah, as long as I get this one up, it should be fine. In the social ninja blade thing or whatever, the social stream ninja, I just see the number. I don't see that you're redeeming something. So I think people are like just putting in a number 7. People use 7 a lot today. 7 looks like you're just saluting me. Like, hey, bother, you know, kind of being like polite and saying hi instead of just fucking farting is the first thing that you do. All right, that should be isolated. Double check, I gotta make sure. All right. No ground. This one's gonna be a beast. You guys have saved those up for a long time. You're in about 2 farts a stream. Oh, you're doing the full night salute with the helmet and everything. Where were we? We were while we were wah wah. While we wah wah. Whip stir, stir, whip. Right, and then this one right here. We gotta isolate the grounds out. Make sure they don't short everything. And these connectors, the thonk connectors, unfortunately, short to the adjacent pins. I was unaware of this, and I went ahead and built this thing. I can't get rid of the solder. That's all right. I can have solder in it. 21 gun salute. Hey, whatever burns those channel points faster for whatever cool thing I build next that you won't be able to operate because you're out of channel points. Ah! Son of a bitch. What'd you guys eat? Is the fart the only sound we have now? I was going to add other peripherals that have different sound banks. We took apart a bunch of those little dollar store noisemakers, but never got around to doing anything with them. They're in a bin. You have 9 farts to choose from. Choose wisely. Your choices matter. I read a huge article about all the problems with Mass Effect and how they originally had this wonderful narrative push where you had the only person that could understand this alien language and you were the only person that could solve this problem. So you need to have a small team to go around the galaxy and gain access. And it was going to be very sort of Star Trek-y, but the narrative was very embroiled in that, and it worked perfectly. And then EA came along and said, like, Shepard is the action man, awesome guy, and they totally ruined the narrative of the whole game. So it's not really the beloved Mass Effect 2 was actually showing a lot of signs of this sort of retooling that was to the detriment of the overall story. And eventually by 3, it was irreparably harmed and unable to be recovered. It was a long read. Yeah, what do you need other than farts? I say, hey chat, can you guys describe to me the ending of Mass Effect 3? And you let out a big wet fart, and I'll go, yup, that's about right. We didn't, look, we didn't, yeah, did EA have that reputation back then? I don't think it did. It earned it in the subsequent years, but when they bought Mass Effect, I don't think we really were too aware of how awesome EA was at making decisions. Burps would be funny, but again, the whole push for the whole thing that motivated the fart box was that I had a fart noise maker, a little dollar store fart noise maker. So, well, it was so the Space Baby ending. You're told throughout the whole game that your choices are super important. Your choices matter. Your choices matter. Your choices matter. And then they go, here, you choose the ending. Huh? But I mean, before the Space Baby, it was bad. It was in very, very bad shape. The Space Baby, while sort of the tip of the iceberg, it's only the tip of the iceberg. There's a whole fucking iceberg below it. And then why do we get a giant comedy Terminator in the middle of the whole thing? That sounds like executive meddling to me. We get the giant comedy three-eyed Terminator. Doesn't make any sense. That thing goes inside of the reclaimer ship or whatever. Doesn't make any sense. At least the side stories were gold in that game. Side stories were very good. All the character stuff. That set of games, I should say. They typically did a very good job with that. Okay, now I'm having trouble heating it up because peeling these up, we're making them into 3D jumpers, physical 3-dimensional jumpers that are going to allow me to use this thing as a splitter like I originally intended. It's supposed to be the easiest circuit in the world. Super easy. You just put a bunch of wires down. But apparently, that's not the case because these connectors like to make contact with their neighbors. What is going on here? Get off. Get off of the pad. Off of the pad. Get off of the pad. What is it doing? It like resoldered itself now. Okay. All right. Okay. All right. All right. It's fine. It's fine. You get flushed. Now bend here. Get off the pad. Oh my God. All right, you wait right there. Probably. No, I do need to go over to the pad because this This is the one that I need to isolate. Is I isolating the wrong one? No, it's isolating this one. Okay. Har, har, har. You know what it is? It's because this isn't above the vise. That's why I'm having trouble. That, like that. This across. What is going on there? Oh, it just... Whoa, buddy. All right, hold on. Oh, now it's broken. I guess I could just use it to connect to the thing adjacent. Huh. The center pin broke, but I could just do that. There. Okay. And then isolate this one. What's up, T-Mister? I screwed up the splitter, whatever, router, whatever. I don't know what you call this in modular synthesizers, but this thing is for splitting a one jack into many. And apparently these thonk connectors connect to adjacent spots. So I need to isolate the ground out so that the ground isn't making contact to my audio signal everywhere. So I'm just wedging the tweezers under the wire, and then oh wait, that's turning there. That shouldn't. This is a mistake. Oh, okay, never mind. It wasn't a problem at all. In some locations I'm using 2 wires because I'm going up and over to get to that center pin. I just need to make sure that it still gets to that pin without shorting to it. It's a little ugly, but it's fine. All right, next one is up here. This one right here, need to isolate it from the ground. This is all just so that I can test Julian's thing and get it back to him. I think he's popping in here this Sunday. I won't be streaming, but he's just popping in to get some stuff. Drop off stuff? I forget which one it is. So I wanted to have this ready for him when he gets here. Oh, I'm gonna clean flux off of my tweezers. No. Did that break the wire? It's okay. I just heard like a snapping noise. I don't know where that came from. Okay, so while this is not something that I would deliver to a customer, it should now work. I'll do continuity test in just a sec here. I want to make sure that was soldered. Okay. So now, assuming where's this thing? If I look at the, wait a minute, hold on a second. I got to think about this. I isolated both of them from ground. So they're always, I mean, they're still going to connect on the right side. But if I check ground here versus the pin, I get OL. Okay, so that's the success. Let's check the other bank though. Bank all the way down here. Check this one versus this one. OL. Okay, good. Good. All right. Repaired. Not in the best way, but it'll work. It'll work. What's up, Tater's game? It's also possible that if I press on it wrong, it'll like short out, but I can't be bothered to do it any more than that. If I wanted to be thorough, I'd put a little piece of tape, sneak a little piece of Captain tape under each one just in case, or put a dollop of UV glue on each of the bridges so that if I come along and I bash it with my hand, it doesn't short out to those pins. As it is right now, it shorts out to those pins. But I should see more reliable usage in putting the oscilloscope on it. So, turn the oscilloscope back on. And I don't mean physically turn it on because that takes 56 seconds, which is an absolutely abysmal startup time. That is just insane that they would allow it to start up for that long. I guess that's indicative of it being an Android device. Apparently those take a while to boot up. 2 banks hooked up to the oscilloscope channels. So now if I put a square wave into one of them, we get a square wave. We get a square wave. We get a square wave. Hey, look at that. That was a definitive fix. Hey, I'm happy for that. Yeah. All right, cool. And now if I plug bank into bank, 2 square waves. Brilliant. All right, cool. Wonderful. Love to see it. So what I can do now is I can put that signal over to there, and I can take this signal and I can bring it over to the bomb 3 or whatever this thing's called, into the input. So from there, I can go into the input to this thing, bada bing, and then I can go from the output to here. And I could also plug that into a scope. Now, what's going on here? This is distract. It's not doing anything. Now, this is about a C note, so feedback. Whoa. Why does it tank everything when I do that? Weird. Tanks everything, doesn't tank everything. Tanks everything. Is this thing heating up? It's not getting hot. I think I'm smelling something. Is there any heat on the board? No, we're doing good. I'm just seeing ghosts. So in level, turn that all the way up. Why is that so small? Is this meant as like an audio output? Why isn't the in level much larger? Time. Doesn't seem to do anything. Effect. Doesn't seem to do anything. Maybe you got to listen to it to hear. And then these are, what is that called? DSTRCT. Distract, maybe? But do I need to have a CV coming in here? And this is effect only. Okay, that looks a lot better. That looks like something's actually happening. Also, we can switch the waveform. Dead channel. Next. There's a sine wave and what it's doing to the sine wave. Okay, so when these bottom out, it looks like they're bottoming out the whole device. Audio level is at full. Oh, here we go. What's that knob? That one is feedback. Wait, feedback just lowers the... Is that one actually volume? Am I looking at the wrong panel? No, it's Dive Bomb 3. It just feels like the knobs aren't doing what they say they do. Like this one is clearly level. Yeah, clearly that one's level. Wait a minute, that's not feedback at all. What is this one doing? Oh, it also does something similar to level. Are they both level? I'm level at you. I don't know. And this is on effect only. If we're on the actual output, whoa, it's super cut off. Something's fishy with this thing. It's not exploding, so we at least have that going on. But it is not quite responding to my full force audio the way I would want it to. What is channel 2 set for? Same scale? Why is the scale weird? Why is the scale weird, stupid channel? There you go. Okay, so we're at the same scale for both channels. Same scale for both channels. The transistor down here. I don't really have a CV to put into it, but I could try putting one of my audio type signals into the pin. If I had a wire, do I have one over here? A bunch kind of sitting over there. Let me go get another cable. I don't know, I'm missing one. Where are the cables? They're under this thing. Oh God, it's the sun. Oh, dear God. Okay, back over here. I got an orange one. Oh no, I got a pink one. It's a CV in, and it's going to be a little fast for a CV, but I can just take the square wave, put that in, and we can see the LEDs basically flickering, probably at that rate. So it's a little distracting because it's not really a good control voltage, but I guess that's what's going into the Vactrol, and then I don't know what you do with it here. Oh, there's definitely an effect. It does something. We don't need channel 4 or 3. There we go. I guess I could plug the scope into the other one, but don't know what precisely is really going on there. So this is taking it to plus minus 3 volts. Why? There's a bit of a delay. It's not much. The big one here is time. It doesn't really do much. I don't know. Julian's going to have to try this thing out because it's doing stuff that we can perceive on an oscilloscope, but we don't really know what this is going to be like for the actual modular setup. But I do kind of feel like something's still a little bit wrong with it. We are 180 degrees out of phase from what I can tell. Although this is a repetitious signal, it's not asynchronous, so it's the same exact signal over and over again, so it kind of looks like, even though we're 180 degrees out of phase, I don't know if that's 2 phases or not. But the time knob, that's effect. The effect knob all the way down. Time knob gets us from like unstable. What's going on there? I feel like I'm losing it. Yeah, I don't know of a documentation on it. I looked. We've got the official web page open, or the where you can buy it from, and it's from it's on Etsy, and there's no other like web page that they're really like citing. It'd be nice to know, but and again, my testing stuff is kind of limited. This is modular synthesizer voltage audio outputs. It's not. I need like a slow one that I can also put into stuff. But from what I can test, from what I can tell, this thing works. There are some quirks with it. Julian does have another one of these chips, though. If he really needs to, he could probably toss another chip into it. And so far as I can tell, in terms of capacitors and stuff, this thing is fine. If if I really should put water wings on this fucking thing and cut the traces, maybe cut this 5-volt, the 5-volt trace right here coming into the input, and put a diode on that. I should put a diode right there just to keep Julian from blowing this thing up again. Because I mean, what we saw, this fucking murder scene of a regulator that we took out. Where did that go? Where did that go? I need that to be in a special spot because that thing died a warrior's death. Honorable death. I don't know where it went. It was under my hand for a while. Oh, here it is. I put it way over here. Try to keep it safe. I didn't have a synth explosion. Julian did. And he says he thinks he might have put in the capacitor the wrong way, but 78LO5 is not the most sensitive piece of equipment in the world. That's why they love using it for beginner projects. Oh yeah, they come in all kinds of packages. When you get into the world of packages, my friend, there are a lot of nightclubs. I mean, there's a lot of stuff that chips come in. All kinds of packages. 78LO5 is really great for if you need 5 volts. You need 5 volts. You don't want to spend a lot of time and effort, and you don't mind that this thing is like super duper low power. It's like, I forget what it is. It's like 500 millivolts or something like that. But you know, this thing will power your tiny electronics from 1990, 1989. There are much better regulators out there to use for even for general purpose tasks. But these modular synthesizer dudes are sometimes kind of caught in that weird era of DIY electronics that brings you back to like early 90s technology. Yeah, and having a heatsink is so nice, even in the surface mount versions. There's a little piece of the silicon there that's cracked. TO220 goes up to at least an amp. Yeah, that's cooled. Tradition is good. Not this kind of tradition. Listen, this existed in a weird spot. 78LO5. It doesn't have a heatsink. It's for like super low current jobs. The ones with the heatsinks are so much better. But if you want like great power, look up Pololu. There's a lot of good regulators there. Anyway, the point is, this could not have happened if a capacitor was backwards. I don't think. Because those electrolytic capacitors, while sensitive, are within their voltage range. So they're like 25 volt devices. So they should be in their voltage ranges. They should not have that much trouble. This indicates to me that this thing was plugged in backwards. Plugged in backwards and then it popped off. So the question is, what did it damage along the way? And this is the first stop right here, the PT2399. Julian has one more of these chips, so it might be that swapping the chip out will get this whole thing to work. I don't see any other issues with the assembly. It looks like everything is in good place. That LM317 that's in all of the adjustable transformers from the 1990s era does 10 amps, really? It gets absurdly hot. Oh. What's going on with that? Let's just touch that one a little bit. Give it the hot touch of my soldering iron. I don't see any indicator of any of the assembly here being the cause of this thing working funny, but we got it to basically take power in, and it does stuff to waveforms. So maybe that's all. Maybe that's all it needs. That's in the correct direction. Resistors are installed. Everybody seems kind of happy. What, the sensitive cap right here? It's fine. I don't see any reason why this thing wouldn't work. Yeah, that's installed all right. It does 10 amps quotes safely, but you shouldn't use it for more than 4 to 5 at the drain because the heat produced is absurd depending on the step down voltage. If I were going to do 10 amps with anything, I probably wouldn't be leaving it to that type of regulator that dumps everything, all the excess into heat. Dumping all the excess into heat is the last thing that I want to have happen. All right, I don't see any other problems with this thing. I think everything is pretty much in good shape. I think Julian did a fine job building this thing. I don't know what else there is to it. Is this like a totally isolated Vactrol? Is that what's going on? No, it goes over to this hair. Or it goes to the main time delay knob. Huh. Cook an egg on your 7805s. I think you can. The 317 would be the better candidate for that sort of thing, though. Okay, well, that's repaired, I guess. In terms of the narrative of the show, I'm going to call that and say, we succeeded, everything's great, Julian will be super happy. I mean, Julian's always super happy to get his stuff back, right? Like, that's never out of the question. He's always extremely, thankful and polite and all that stuff, but I would have liked to have a little bit more of an idea that thing was fixed. Make it a little bit more apparent that we had actually repaired the thing. That happens sometimes, and it's also part of the setup here where I don't have the exact things that I kind of need in order to fix things. I don't have quite enough of what I need, like in terms of like setting control voltages and stuff around. This is going to solve that. We can leave that to another day. Okay, well, thank you guys for joining me. This is a sort of a quick little easy thing to do. It's a through-hole kit, 7805 regulator. It's like easy of the easy. This is the kind of stuff where if you get into soldering, you're going to be tasked with repairing things like this, where you have to pull the parts out of the hull, look at the traces that are, or the pads that might be missing, repair something, and yeah, just sort of do that. Let's see what's going on here. Why do I have 2 notifications? Which staff wants to learn about Roblox? That's great. Why do they have to make an announcement for that? Like, okay. Stupid Assassin's Creed stuff. You can now earn the ability for drops to blah, blah, blah. I don't want to know anything about that. Oh man, small crowd today. I guess we're doing basic stuff. What do the numbers look like on YouTube? Let's see what that looks like real quick. At one point, we had over 4 viewers. That's amazing. For YouTube, anyway. Okay. Is people still around? Oh, wait, that's not the way to check. A job well done. I thought you were going to say easy, a job well done. You almost said that. Twitch, TV, oh bother. Muted. Good. Gonad's on. I'm going to send you guys to Flatulent Gonad. That's an easy peasy raid. Flash. Raid. Flatulent Gonad. Boink. There we go. Yeah, we're going to raid into Flatulent Gonad, and I will be back on Thursday. We will work on, I don't know, chat interaction. Maybe we're going to work with 100 volts. Not 100, it's going to be like 60 volts or whatever that regulator for the Nixie tubes puts out. We're going to try to charge a capacitor bank and then fire it off using microcontrollers. I will not be anywhere near these giant capacitors when they go off. So let's go check out Flatulent Gonad, and I will see you guys on Thursday. Peace. What are you still doing here? You have weird settings on your Twitch. Well, guess what? You get nothing.